Well, and good afternoon, everybody. Looks like the audio is working. So far, it's just me sitting here in Discord by myself. But I was late putting out any notifications. I'll shout out Clive and My Mom Bakes Cakes, Sean Hawkins, and Hads. What's going on, folks? This is an absolutely impromptu stream. I got absolutely nothing on my mind. Marcus Dresden, flatards suck. Yes, sir. I think I could pretty much agree with you on that one. Yes, I didn't put out any notifications ahead of time. I just wasn't real sure if I was going to do one today or not. Friday afternoons are not the best time. Everybody's got something to do on Friday night, but I don't know. We'll see. See who shows up. I don't think anybody wants to sit here and listen to me talk to myself, but I would imagine somebody will be joining Discord eventually. And you're all welcome. Anybody that wants to come in, hop in here. JM, what's going on? Got to think of something to talk about, or we'll play some videos or do something like that. Yeah, I was having a little discussion over in Jim Panda's server earlier, talking to a few of those idiots, like Johnny B and Jen. And guess what the topic of conversation was? Of all damn things, Coriolis. I'm getting sick and tired of hearing the Coriolis. Jeff Van Meter, shout out for $9.99. Thank you, sir. I really appreciate that. That gets the afternoon off to a good start. Oh, heads. 4 cheese tortellini. You're making me hungry now. I love that stuff. So I rescued you from Jim's, huh, Fred? Good. Gravity, Coriolis, yeah, all that stuff. My Mom Bakes Case, I get really tired of going over the same damn thing 50 times. Hey, there's B-Ball. Oop. He was in the chat for a second and he dropped out. He'll be back. Let's see, Jeff. I need to make you blue. I think I just did. Hopefully. That should have worked. Yeah, so what have you guys been doing today? Anybody seen anything interesting that we can laugh at? We can always turn on the boys over there in the geometrically challenged server. Except Bev's voice is just more than I feel like stomaching for on this afternoon. Hey, Truth Nerds, how you doing? But I'm sure we can run across something or the other. Yeah, you know, and Truth Nerds brought up Brian Leakey. After I sat down and paid attention to what he was saying, although he explained it in a very confusing way, not uncommon for Brian, when I realized what he was trying to say, he was actually right. Brian may be closer to understanding Coriolis than any flurf out there. Kind of amazing. Sean says, check out Geo's. Yeah, for what? Why? You gonna join us, Sean? Jump in here. And B-Ball's back. Can you hear me?
Hey, sorry about that. I jumped in real quick just to say how you're doing. Say what's up. I can't stay long because we're about to go through this little class here. So
Oh,
just one. Say what's up.
Got to do some Army stuff, huh?
Yeah.
Oh, well. Well, you're not going to... How much longer are you going to be out there? You got another month or two?
I'll be here probably in maybe another month, and then I'll be leaving Hawaii for good.
Will you be sad?
I'm sorry?
I said, will you be sad?
I will, because it's been so much fun here. I've done so much here, and now that I gotta go back to the mainland and no beaches, it's gonna be like, oh god. But I think once I'm done over there, I'm gonna try and come back here for right before I retire.
Yeah, I gotta fix this. I see what I did wrong. I'm giving those guys all kinds of echoes out there. Let's see if that stops it. Yeah, that should have done it. Yeah.
I mean, I can remember the first time I actually jumped into a live stream. It was here in Hawaii, and it was I think it was Sean G's channel. Was the first time I ever spoke. In Discord or on a live stream or something. I think it was Sean G. And I remember the first time I made an observation and I brought it to them to show them, and they were like, "Oh no, I think you're too low to the water, and this would really be good evidence." And it was of these two islands on the other side of the island. I really don't go to that much.
Yeah.
And when you're close to those islands, there's like a strip of land that you don't see until you're closer to it. And when you're like far away, you don't see it. And I thought that was, at the time, I thought that was really compelling. I mean, it kind of is, but there's only like 14 feet of it hidden. But that was like the first time I actually offered some observations.
Yeah, I think the first time I met you was on Sean G's channel. Yeah. I believe back in the day.
Yeah, that's back when like Nathan Thompson used to come on there, and
yeah.
Who else? There's a lot of other faces and names that used to go on there.
Nathan Thompson would show up. Old what's his name? No Beliefs. Jeez.
I forget his name. Oh, man. Yeah, I know exactly who you're talking about.
Yeah.
Yeah.
He would come on there and wreck the show. But everywhere he wrecked the show everywhere he went. That was just him.
Yeah.
Damn,
it's cool to go back and listen to a lot of this. All those shows are still there, so it's cool to like go back and just pick any random show and just listen to it.
Yeah, there were some good ones back in the day with Jose too. But he lost most of those when his channel got hacked.
Yeah, I know. That's why it's good to like back up everything you have. Like I have all my stuff backed up just in case something crazy like that was to happen. I could just start another channel and re-upload everything. So.
Yeah.
But doing like backing up 2 and 3 hour shows, it's gonna take a lot of data.
Oh yeah.
I mean a lot of storage.
Yeah, what I still need to do is, and I do need to do that, is go through and back up all that Cavendish stuff I did. The rest of
absolutely. Just in case something happens.
Yeah, these live streams I've been doing lately. If I lost all of those, that wouldn't break my heart. And I've got all the videos, of course, that I uploaded. I've that stuff's all safely tucked away, so I could always go back and reload it.
Yeah.
But the stuff that's not is a lot of the Cavendish live streams, and those are pretty valuable to me.
Oh yeah.
Yeah, it is and it isn't, I guess. Some people wouldn't give a crap, but at least I can point at it right now and tell people, if you don't believe me, go watch. There's 200 hours of that shit. Go look at it.
Yep. Exactly.
I wasn't kidding. I actually did all that stuff. You can see me do it.
Mm-hmm.
Yeah.
I think, like I had said before, that this is what you did, and what there's a few others. It's probably one of the best, best things to offer this community with that, and then with the mage thing. Like those things are where someone went to put money into what they were doing, spend a lot of time to actually go out and do something. I think it speaks volumes to just to the dedication of just actually just doing something. And we don't see that on the other side. We don't see them trying to do anything. We say, hey, go out and try this. If you don't believe me, go out and try it. And they don't want to do it.
You see a very few of them that are willing to actually make any kind of effort. Brian Leakey is one of them that actually
At least
he gets out there and tries something.
Tries.
Yeah. A lot of what he does is well, not. I'll just say it's not the way I'd do it, but at least he tries.
Yeah,
that's right.
He tries. It's funny. We laugh. He does it. We laugh at him because sometimes it's just wrong, but at least he's trying.
Yeah. Yeah, I give anybody credit for taking a stab at it, but then you get these guys like Chris. What's his name? And
Chris Berry.
Yeah, Chris Berry and some of his foolishness. I'm sorry. I mean, it's embarrassing, man. Don't do that kind of nonsense. I mean, my God, that Cavendish thing he tried was just phenomenally stupid.
It's like deliberately doing it wrong, purposely.
Well, yeah, anybody can break it. I mean, anybody can do that. You don't have to be very talented to mess it up. That it's just very discouraging when I see guys like that, or that silly shit that Anthony Riley did, and then try to represent that like it's science. Bullshit. Absolute crazy. Hey, Shaky.
Let me not include one of the most important things that I would need for this experiment.
Right. Right. Yes, absolutely. I'm going to prove that stepping on the accelerator in my truck is what causes it to go forward. I'm never going to talk about the engine, transmission, differential, anything like that. I'm going to run a test and prove conclusively that all I got to do is put my foot on the accelerator and the truck goes. Yeah. That's exactly what Riley did. Exactly.
Yeah. All right, Blue. I got to get out of here, man. If you're still on later on, I'll jump in. I'll probably be gone for about a good hour or so.
Yeah. Okay, man. It's afternoon for you, right? Or lunchtime. Before lunch, isn't it? Yeah.
What's up?
It's early in the day for you still.
Yeah, it's about 10 o'clock.
Yeah. Yeah, if we're still hanging around, jump back in.
Yep.
All right, man. Hello, Rob Martin.
Yeah, good morning, Blue and others, or afternoon in you guys' time.
Afternoon.
We're leading the world again down here.
Oh, yeah, you guys always do. Hey, Shaky.
Hey, Blue. What's up?
Nothing much. Just thought I'd hop on. I had got nothing else to do on a Friday afternoon, so do a little quick stream and see what happens. I have no plans, so we can do whatever we want to do, I guess.
Did you understand what Brian Dickey tried to show in his video?
After I watched it several times, yeah, I finally understood what he was getting around to.
And that was?
We're talking about the Coriolis video, right?
No, a new video I saw on Jose. I don't know if it's new. It's about flight.
I don't know. I'll tell you what. I've not. I think. Let me get over here on the other screen and I'll see if I can pull up flat Earth tests and let's see what we got. Something about South America to Australia. I don't know.
Yep, that's one.
Well, I'll tell you what we could do. We could watch it
together.
Yeah, we can watch it together and see what he says. Hang on a minute. Let me get things rearranged here a little bit. Let's see if I can get all this to work. Now, let me see. I got to punch all the right buttons. Take me a second. I will figure it out, I think. Yeah, I think I got it set properly where you can hear it. Hang on. I'm not showing it on YouTube quite yet. I'm gonna turn it on and you can tell me if you guys have the audio.
So if we take the UN map and call it our flat Earth map.
Did you hear that?
Yeah, I did.
You did? Okay. Well, I guess all we got to do then is let me get one of these screens up like that. Get rid of that chat widget gizmo. Now we got it going out to YouTube, I think. Let's watch this. It's not very long. It's only 3 minutes and 25 seconds. So let's just watch it and see what Brian's got to say about this stuff.
So if we take the UN map and call it our flat Earth map, and we go off the information that the equator is 24,000 miles around, and that breaks it down into 8 sections of about 3,000 miles each. So judging by that line, that puts us at about 8,000 miles. But we cut inside the equator. We still stayed even off Mexico. So the next line is 2,000 miles. So if we straighten them out, we get about a 6,000 mile flight. So that makes the speed of that flight about 490, maybe 500 miles per hour. But let's say we, you say, well, on a flat Earth, the equator would be a lot bigger. So we'll use like 34,000 miles. And that comes out to around 9,500 miles. And that's still not crazy. That's still that's 640 miles an hour. There's 7,500 miles, puts it at 535 miles per hour. 9,000 miles puts it at 642 miles an hour. That's judging the Earth, the flat Earth is 34,000 miles around. So where's the problem? So let's bring it down to reality, okay? Instead of the straw men we get from these anti-flat earthers where they show a certain map and show the worst possible scenario on that map. So look at this notable flight here. It averaged 1,114 kilometers per hour. Is one of them long haul flights that they're using. And that's an average, okay? That's almost 700 miles per hour. I think it is 700 miles per hour, or just barely under it. So no matter how you stack it up on a UN map, even if you make the equator, 34,000, even a little more, it's going to be under 9 or well under 10,000 mile flight.
So as we look at the Great Circle route that you would take going from Chile, Santiago, Chile, across the Pacific Ocean all the way to Sydney, Australia, you would take this route, which is exactly as he said. You would start out first going south or southwest, and then you would take a little portion of it going west, and then you would go northwest. So that would be the lineup.
I was looking at their compass, and their compass at one particular point was reading northwest, and my compass was reading west-southwest. And my compass stayed reading west-southwest for the entire journey, the entire journey that I was awake anyway.
So just to kind of show what he was saying, he said every time he checked his compass, he was getting a southwest reading, which a flat Earth would show. And on the on-screen video display on the back seat of the seat in front of him was showing a northwest, as the globe would show. He had been asleep for 5 hours, he said, but when he woke up, the plane was showing the portion of the trip as northwest, but his compass was showing a different reading of southwest. He also claimed that his compass remained in the southwest position for the entire remainder of his flight, and then he went home and checked the compass against many others, a digital compass and another compass, and said his compass was working fine. So we'll listen to the rest of this and watch the video of him showing us exactly what anomaly he found.
But I was asleep for 5 hours during the journey. But every time I checked my compass, it was pointing south-southwest. And I find that a bit strange, that I would be flying south-southwest all the way from Santiago to Sydney. It didn't really make a lot of sense to me. So that's a weird thing. Whether there's some weird electromagnetic interference in the plane that's causing my compass to do weird things, I don't know. But I took the compass, I took a little video of the compass on the screen, and I compared it with my compass sitting on the table, pointing directly straight ahead to the nose of the plane, and I was getting a different reading. So that's something that made interesting.
Well, that's amazing, Max. I mean, if you look at the Gleason's map, if you were traveling, you would be going west-southwest the entire way. So, I mean, those are the kind of things that are important because they are not possible on a globe. And so these...
So if we take the UN map and call it our...
All right. Yeah. That was interesting.
Yeah, because the line Brian drew wasn't west-southwest all the time. It began north. Why he claims you fly south-west all the time?
I don't know.
Unless he forgot what east and west are.
Well, you never know. I suppose that's a possibility too. I'll have to sit down and look at that. Spend a little more time and analyze what he's really. What that was Jeranism, right? He got that up. That sounded like Jeranism.
I don't know. But anyway, last I asked Brian, he said west and east are perpendicular to the north and south. And what we see there is that you start on his map, at least you start flying northwest.
Something's fundamentally wrong with that. That heading is going to change all the way through the flight. If the airplane's flying a great circle route, your magnetic heading is changing constantly.
No, that's okay. It's on his path. It's also changing.
Yeah.
Only he start heading north and he ends heading south. And the guy said, you on flat map you will fly southwest all the time, which is not true.
Yeah, I don't know. I'll have to watch it. I'll watch it again tonight and see if I can make any sense out of it.
Making sense out of what they mostly say is difficult.
At best, if not impossible sometimes.
Yeah, well, they don't know themselves, so that's the problem, you know. Their map's completely wrong, you know. Like, I mean, they draw a track which then doesn't correspond to what they say.
Yeah.
You know, the two things are out of phase, so to speak. they've got their mouth talking one thing and their map says something else, and they don't even agree with their own, graphics, so to speak.
Yeah. Why did he pull up the UN map? That was what we were looking at.
Reasons?
That actually didn't
The UN
make...
now?
Because it shows the Earth is flat. Blue, come on.
Or it just looked cool in the logo. That might have been better. Better explanation.
Did they actually turn it 90, 80? Did they actually turn it 90 degrees from the original logo?
I don't know. Honestly, don't know what that is.
Well, one thing it isn't is a navigation map.
No, I don't think I would feel very comfortable climbing in the left front seat of the airplane with that thing in my lap.
Well, we don't know the distance when we fly. We can't figure it out. Just according to Witsit.
Why is that?
We just sort of take off and hope we get there, Put 500, 600 people in the back and just kind of wing it.
Oh, sure. Yeah, you don't need to worry about it.
We have no idea the distances because we're out over the ocean and you can't tell because GPS doesn't work.
Oh, we just tell them to fill her up,
Yeah.
Top those tanks off. Maybe we'll make it.
Yeah, you can do statistics based on prior flights. So
Absolutely crazy. That's the one area I think that's probably got the most misconceptions of all surrounding it in this whole discussion. Anything to do with aviation, those guys are just crazy.
Oh, yeah. Anything to do with aviation, no flat earther has a damn clue.
Yeah.
And every once in a while, they'll trot out a quote-unquote flat earth pilot who I don't think is either is not a flat earth pilot or I don't know. They just quote at them. Some of these guys are even pilots.
Or it's some guy that's all he's ever done is fly a Cessna not more than 150 miles away from his home base just to get this one long distance cross country in. But
follow the road. It's probably the safest way to do.
Well, they're flying under visual flight rules, and there's a big difference between flying under visual flight rules and flying under instruments. It's a completely different skill set.
Yeah, there's a little more to it when you start flying on instruments. Flying flight plans. All of a sudden your precision needs to be a little better.
And there's a thing that you just said, Blue, plan. And that is a huge part of commercial aviation. You don't do anything without planning it.
Isn't that the truth? You best not be doing that in civil aviation either. If you're taking a
GA,
trip,
yeah.
Even GA, if you're planning on going on a decent length trip, you better sit down and do some planning. Oh, it's okay if you're just going to hop over the other side of the mountain and have one of those $150 hamburgers and then come home and you've done it 20 times. That's fine, no problem. But I don't recommend that, especially when you're going somewhere you've never been before.
Well, every once in a while there'll be somebody that I just read an accident report. These guys lived in New York and they went up to California to get an airplane, and they stopped in Aspen as their, to go back east to refuel. And that may not have been the wisest choice for these guys because they went into town, came back, took off, circled the airport twice, and flew into the mountain to the east.
Yeah, I forgot about density altitude.
Yeah, they forgot about density altitude. They forgot that their airplane barely climbs at that altitude.
Yeah.
And they didn't gain enough altitude before they turned east. because they also forgot about the downdrafts. And the other thing they did, is they flew right down the middle of the valley, which means they couldn't turn left and they couldn't turn right.
I'll tell you, I've had the experience many times of spending afternoons or weekends flying around looking for airplanes that didn't make it in these mountains down here. The Flatlanders, guys from up north, who've never flown, and we don't really have mountains. I mean, I live here close to the Smokies. Highest thing we've got 6,600 feet, but still, that's huge if you come from Indiana, and you've never flown around these damn things before. And it seems like once or twice a year, somebody would depart from somewhere in Michigan and disappear from the radar down here over the Smokies.
Are they thinking about mid-sector altitudes or something?
No, they just, some of what you're talking about, they don't realize that you better leave some clearance below you
All right.
going over those mountains, especially if you've got some wind, because you can get some really funny downdrafts, and you can't, and a lot of those little GA airplanes don't have enough horsepower to get you out of it, So.
Yeah, forget about the men crossing altitude and stuff.
Yeah.
Altitude above you is one of the most useless things when flying in the mountains.
Yeah, the altitude above you, the fuel that's still in the truck, and all that runway right behind you, that's useless.
Field grade navigators.
Yeah. That's a fact. Had somebody else in here for a second. Steal somebody, I forgot. I didn't catch who he was, but he never said anything. So if you're listening, hop back in. I wasn't being a very good host. I should have welcomed him. I'm neglected to do so. Maybe he'll be back. I see George is in here too, but he's deafened and muted. What's the craziest shit you heard today, NASA?
Oh, God, there's been so much of it. Well, can we start off with the basic that the Earth is flat?
Did you listen to that go-around I had with Johnny B over there on the...
Yeah.
God.
Johnny B and who's the other? Tom. He's another idiot.
Oh, yeah. Yeah, every time you point out what an idiot he is, he just laughs like a fool.
Well, he was having a big problem with the bridge on Lake Pontchartrain.
Yeah, I wonder why that is. Could it be that it's pretty solid evidence that the Earth is not flat?
Well,
I noticed that none of them are willing, even though you've got people like Rakia that claims to apparently lives very close to it and refuses. But I mean, he's in the ideal position. He's, according to him, he's got all the money in the world. Well, go rent a damn Tremel R10, put it on your car, and drive across the bridge and record the elevations and all the XYZ data. Tell us what you see. Think he'll ever do that? Hell no.
Because they know what they're going to see.
Right.
Exactly.
And they don't want to see it.
For the same reason they won't do the Eratosthenes measurement in their backyard. It'd be easy to do.
Yep.
That just proves they're dishonest.
Yeah.
Either that, or then the second thing you do is next time you're on an airplane, go download an app and you figure out the dip from your altitude to the horizon and do the Eratosthenes, not the Eratosthenes, the Alberuni experiment.
Sure.
The thing you need to do is ask the pilot what altitude he's at.
Well, these days you see it in front of you. Most on a lot of, especially long distance flights, it's all there in front of you on the screen.
Yeah.
Yeah, that's cool. I like having that. Although, on an overseas flight, you catch yourself just sitting there staring at that thing thinking, move, hurt, come on, move.
No, the US is kind of big, unless you're in the Concorde. And I was amazed at how high the Concorde flew. I knew it flew high. I didn't realize it was right below the Armstrong limit.
They flew at about 60,000.
Yeah, 60, and the Armstrong limit's like 62. And they couldn't go any higher because then they'd put everybody in spacesuits, and they didn't want to do that.
And I'd imagine too, if you go too low, the air friction will be greater and the plane will heat more. So there'll be an ideal altitude for height, for air density, I should say, for the speed they're going.
Oh, it was specifically designed to fly at Mach 2 at 60,000. That's what they designed it to do, and that's what it did. I think when they were up in cruise, they were never off that 60K number. That's the place they wanted to be.
When they came into New York, they were always min fuel too. They got priority routing. They barely had enough fuel to do it.
Yeah, that thing was right on the cusp all the time. Yeah, they never landed with a whole hell of a lot of fuel left. I don't think winds ever really had any effect on them. You don't really have any jet streams up at that altitude.
Yeah, so you're up above them.
Yeah. Yeah, the jet streams are usually in the 30 to 40,000 range, somewhere in there. Mid-30s, pretty typical.
Yeah, Witsit was having a huge problem with the 800-mile-per-hour flight that happened like 6 months or a year ago or something. They had like a 250-mile-per-hour tailwind there, like just over 800 miles per hour ground speed. And he was convinced that they were lying. They didn't know the distances. Blah blah blah.
Well, there are those unusual weather conditions.
Well, and when I tell them that that's the result of Coriolis, they really go crazy.
Yeah, that's what smears it out.
And when I tell them that airplanes do have to worry about Coriolis because there are these things called winds, they really go crazy. But the main cause of the west to east winds that occur throughout the world, at mid-latitudes especially, are the Coriolis.
Yeah. Well, if the Earth wasn't spinning and Coriolis wasn't a thing, the predominant airflow would just be from north to south, or south to north, actually.
South to north. And if the Earth had no land on it, the tides would be a whole lot easier to figure out, too.
That's a fact. I've still not heard them try to make any legitimate attempt at explaining how tides work on a flat Earth.
No. They mostly point at the problems with the tides because of the land and the bowls. Or there's some places where they're like in the Gulf of Mexico. It's a really strange tide table. It's once a day instead of twice a day. And the Bay of Fundy with its 42 feet tides and stuff.
Yeah.
Well, the land complicates the tides.
Yeah.
The water's effectively flowing. There's a tidal bulge that has to move, and so it flows. And here in New Zealand, we see that where it flows up the coast and around, and you get the tides sort of progress. When you look, they progress from south to north. If you look at the high tide
Well, you got a couple. You got a couple New Zealand flurfs around here, and it always cracks
Yeah, I
me
know.
up.
Yeah, it's mate. I just can't shake my head. You go.
Yeah.
For
So
fuck's
like,
sake.
go outside at night, look south, and see
Yeah.
that things are not the way the QE tells you they are.
Yeah.
Then,
And even take a photo of the moon, and it's upside down.
well, that
yeah.
could work on a flat Earth thing. I mean, if you put a picture of the moon and then on your bed, on your wall of your
And rotate it,
ceiling,
yeah.
and then go to the other side of the room, it'll look upside down. So that might work on a flat Earth, but the stars won't.
No.
Yeah, but the moon and the sun have to rotate once a day on their model.
No, we're not going to get
And
in that one.
we don't know how that.
We're not going to get in the whole fact that the sunset doesn't work, and the size doesn't work, and the speeds don't work, and this doesn't work.
Hey, it's easy. Nothing works on their model.
There
Nothing.
you go.
A couple things might work. The moon
They have
might
a
work.
model. They have a model now.
Well, no,
No.
of course not. Because then they. The reason they don't come out of the model is because I think they learned from the. Remember, a couple of years ago they said, "No, you can't look at the sky to tell the shape of the Earth." And then suddenly one day, celestial navigation proved the flat Earth, and that was hilarious. That means that the sky is now in play.
Oops, had the mic turned off. Yeah.
Yeah, it's hilarious that they don't understand that you can only work out what you're doing with reference to something else, a static reference system of the stars or something, and they say it's somehow unfair to use that as a reference system.
Yeah, MC Toon has still got his $10,000 out there, and it's amazing how nobody's claimed it. I mean, he put $100 out, and somebody claimed it in 4 minutes, I think.
That was Bacon, yeah, that's right. He did it. He's got that.
It wasn't
Bacon.
me. I was working on it, but Bacon had it programmed in the computer. He just plugged it in and moved. So
yeah, and I think Larry has also got a spreadsheet set up to, which I keep on being set up as well, just to convert local sort of azimuth and altitude into declination and thingy coordinates. So if you've got a spreadsheet set up to do it, then you can do it pretty quickly. So yeah, I think if Bacon's got something set up to do something similar. So yeah, if you just plug in the thing straight away and off you go. Yeah, I must set that up. Okay, there was a thing yesterday about the Coriolis thing I was getting. I've decided I've resolved my problem with that, and it was all to do with the fact that the equations that I've been that on Wikipedia and the ones I've in my book on mechanics and things. Of course, they're assuming that the rate your movement is following a constant radius.
Right.
And so immediately you I know there was some talk. I think the captain and Chaiki actually brought up a change of radius in the in his one of his diagram about the motion. And of course, if you're changing the radius, then you have to modify the equation, take that into account in the equation. That was my little problem there. The equation assumed a constant radius, but obviously, if you do like far up or something, or the thing's not following a radius, then it does actually affect it. And Chaiki was actually correct in saying that if you point it up at a long distant mountain, as opposed to pointing it down, that's obviously you're going to get two different effects. But the equations that we're more familiar with, you'd have to modify them to allow for this change of radius, because it's the differential of the radius of your position. Is the Coriolis has got a velocity when you do to work out the formula. You one of them is the velocity inside the inertial reference frame, and then there's the one in the non-inertial reference frame, and one of them is the differential of r, which if you're changing r, then changes the equation. So yeah, that was my problem I was having yesterday. And of course, I was saying if you fired horizontally from the equator north to south, then you weren't getting an effect, and that was troubling me. And of course, you're changing the radius if you do that. So that's where I've resolved my problem with that anyway. So that if you are firing a bullet perfectly horizontal at the equator north to south, and it doesn't dip at all, then effectively you've got the same case. I think Bluey may have mentioned this as being a cylindrical system, because you're not then changing the radius. Yes, I think you did mention that. So that's why. But of course, that's not what happens when we talk about firing a bullet or something, and we sort of assume it carries on the sort of similar rate. So it actually drops, of course.
That's where that was giving me trouble too. The same thing.
Okay, we're both having the trouble, right? Yeah. So obviously, so in other words, these firing tables for artillery and things, they must allow for all this, of course, because they're obviously firing quite a lot higher up. They are following a sort of angled trajectory that Cheike sort of drew on his diagram. And
well, it's latitude dependent too. Go ahead, Cheike.
The trajectory doesn't matter really. It's where
well, if
your
we're changing a
target
radius,
is. Well,
if we're changing
your
a radius,
target, right. So if the target
you
is
drew a
very
diagram.
higher, much higher than you, then it's a problem. But that doesn't happen on Earth, right? Not in wars, not where they fire.
Well, I don't know what the well, yeah, I'm just trying. Okay, I haven't done the calculation for the firing artillery. I mean, those howitzers, for instance, in the Ukraine, whatever those M77s howitzer things, they fire what about, is it 40 miles or something? I don't know how high they go up to do that. I don't know. I can't remember what the trajectory is. I think they almost fire at 45 degrees, so I think they must go quite a decent, I don't know, 10 miles up perhaps.
I think ballistically the max trajectory, maximum range occurs right around 45, maybe a little less than 45.
It is a bit less. If you take into account air resistance, it's actually less, yes. It's nearer 40, even less than that actually. I think it might, for something like a rifle, it might be down to something like 35, but with a big artillery shell, it's a bit closer to 45. Because if there was no air resistance, it'd be 45.
Yeah.
But with air resistance, it is less than that. So I was just, so I haven't done so I don't know how high those things go up, and I'm just wondering, I haven't checked this out yet, but I'm presuming that might have some effect on the calculation that you have to do for when you're fighting in the Coriolis calculations that these pieces of artillery have. Presumably, I don't know. I'll have to see how significant it is. But obviously, it's the diagram that Cheike drew yesterday with this dirty great big mountain that was obviously a good fraction of the radius of the Earth. Obviously, you'd have to take quite a lot of extra calculations there, but I don't know whether that's significant for.
Yeah, I haven't had.
Go ahead.
Haven't had the time to check it out yet, but Walter Bislin responded and said that the firing tables, artillery firing tables, actually show that effect.
Oh, really?
Yeah, it's built into
the height
it.
Dependency.
Yeah. Mm-hmm.
Right. Okay. Yeah. Well done, Walter.
Yeah, depending on what your, what your latitude is and how elevated you've got the barrel of that thing, is going to determine whether it's going to move to the west or to the east.
Yes, obviously it's latitude dependent, but I was adding in this extra complication of the change in radius as an additional complication over and above the usual calculations that that are offered on Wikipedia and things. But I've yet to. Yeah, I haven't read that book yet that Eric kindly gave us a link to. That's quite an interesting book, but it's got some odd notation. But I was going to give it a little read. But yes, so there's extra complications. So when you actually want to do it in real life with artillery, I don't know if it's significant, but if it's I mean, Everest is 29,000 feet. So presumably, I suspect if they're firing a shell over 40 miles away, it's probably going higher than Everest or something to get there.
I would imagine.
Off the top of my head.
Yeah.
Yeah, intuitively.
I would imagine it's pretty high.
The V2 was the first thing to hit the stratosphere or go out of the stratosphere, something like that.
The V2, right? Yeah, I mean that was another thing that was basically ballistic. That just sort of. I mean, in fact, I hadn't realised this, but the ballistic missiles we talk about, the intercontinental ballistic missiles, they're called ballistic because, in fact, all they do is they fire them off for the first, 2 minutes or something at full whack, and for the rest of the time, it's all a glide. That's why it's called ballistic.
They have a little bit of cross range these days, but yes.
Right. I mean, obviously they can sort of glide back and sort of, I think, wiggle about a bit on the way re-entry, but fundamentally, they get their big push at the start, almost like a gun. And from that point, it's basically a ballistic trajectory with some wiggly bits at the end if you want to flap about a bit with alter your wings or whatever to come back down. So I hadn't realised that's why. I just thought ballistic in that sense. I hadn't really fully understood what was meant by ballistic.
Which is why they want to know the geoid.
Yeah, it'd be quite important. Yes.
John Rapp says, I believe Clive Wells' formula yesterday takes into account the constantly changing velocity, most notably the direction.
Yes, he's saying you'd have to integrate. It is a complicated operation. If you said, I want to know what the deviation actually is, you do have to, as Clive said yesterday, you'd have to integrate it because it's changing all the time.
Right.
And I've seen a number of globers attempt to work out what the actual deviation would be, but of course as it's an integral because it's a differential. Each time you're moving along, it's changing. So you're changing your angle as you're going along, and it's always right angles to that, and so. It's a very complicated subject, but yes. So I think Clive did a video, as he said, he did a video on this about a year or so ago, and I can't remember. It wasn't a good video in terms of being able to understand what the hell was going on, or something was out of focus, or something dreadful was wrong with it.
I went and looked.
He has another go at it.
I went and looked for it, and I didn't see it on his channel. So I don't know if he took it down.
Perhaps he took it. Perhaps he took it down after I moaned about it, because. Clive obviously can do his stuff, but golly, he does make it hard to understand what he does. I think he doesn't give any help at all to. You need to.
I think we're all pretty good at that, apparently. We've yet to be able to make any of those idiots on the other side of the fence understand anything.
Yeah, I mean, something like Coriolis is a real challenge. I mean, I suspect that 80% of globers, possibly more, don't understand the Coriolis effect and certainly don't understand the equations. So there's absolutely no chance of a flatty doing it. But other subjects like what was it? There was one you had on yesterday. You were going through, was it molecules and things? So more basic. Yeah, we can't even get the more basic things over and but well, this is again back to Sean Hawkins' thing. If they don't want to understand, then you've got real problems. But I think they also genuinely don't want to understand as well. I mean, obviously, if you don't want to understand something, you can still accidentally understand it. If even getting through to the Oakleys and the QEs of this world, if you make something really compellingly clear, they have no option but to understand. That's what I try and do. I believe in making something so crystal clear, so compelling, that even if you are willfully ignorant, willfully trying to reject it, you just can't stop yourself but understand it. And that's getting to that point is where I like to try and get to. Basically with diagrams, of course, because they can't understand maths, they can't understand a verbal explanation, and that's why I always go for pictures. The only thing they can understand is pictures.
Yeah.
And so please find this as well. And so I think there are times you can force them. I mean, I've managed to get over the years Oakley to change his arguments when I've forced him to understand something that he was wrong. Not on every subject I've encountered, but there have been a number of times when I forced him to change his language because he was forced to understand what I was saying because I made it absolutely compelling. But something like Coriolis, you need those tools. They need to have some understanding of what the hell's going on in maths and things and geometry and think in 3D, which they can never do, of course. And it's just too much for them. That's an insurmountable challenge. But some of the simpler stuff like the molecules. There was one you were showing yesterday, QE did on molecules and things. Oh, that's what we were trying to explain about. He didn't understand that you could have a random motion of things and a net motion, which I say, even that example I gave of a bath, where you've got all the molecules doing their own thing randomly, plus there's a net motion. That I couldn't get through to John. At least I only had one go at it, unfortunately. But even simple things like that, because they don't want to understand it, they don't.
I wonder what he thinks goes on inside his automobile when he drives down the road. How does that work?
Indeed. Where it's all those molecules or something in the combustion chamber, or do they all stop moving randomly, or just move in the net direction of the car? Yeah, God, honestly.
Oh no! See, I found this diagram that I thought explained Coriolis quite well, and they refused. I don't know. It shows both the straight and the curved motions.
Blue, Clive has posted a link to that Coriolis video.
Excellent.
So was that paid, NASA?
Yeah, he's. I don't know. I'm not sharing my my screen with you guys, but it's in the chat there.
Live chat.
Yeah. So just pull it up. Yeah, it's showing.
I thought this was pretty clear, and they don't get it.
Well, that's what it looks like on a flat rotating disc.
And this would even be Jeremy's ball thing, where he's throwing the ball over the merry-go-round. To the guys on the merry-go-round, it traces that path. If the ball was dripping paint, it would drip paint in that little curlicue path out over the merry-go-round.
That's exactly right, and it doesn't make a damn what it's doing in some other frame of reference.
From the frame of reference to the people not rotating, it would appear to go in a straight line, but
sure,
it would appear to make this little. There's a big fancy term for this little curlicue thing,
but if we're trying to follow that straight line path over that rotating disc, we're going to have to be doing some corrections.
And of course, this is the view that we don't have, and this is why they say, this is what their classic thing is but it's not a real deflection. It's not a real deflection. Is the yes, in fact, that was I think in that video of the QEs you were looking at, I think he said he had a 5-minute section in which he said it's an apparent deflection. It's an apparent deflection. It's an apparent deflection. And he gave up lots and lots of citations of apparent deflection. And what does that? And he said, what does that actually mean? It means it's not really happening. So you need to substitute the words "not really happening" for apparent. But what the stupid moron does, if we had this diagram that played down here from the perspective of the us on the planet doing this, or as the thing is rotating, it would look as real as anything else. And if you see that video of some people in a room, this solid room that's rotating, and they throw balls to one another, as far as you're concerned, from that reference frame, it's as real as anything else.
Of course it is.
See, they misuse the word apparent. They think apparent means make believe, when it means just basically means it appears to be that way.
And this is what was QE spent 5 minutes going over and over and hammering home. It wasn't really deflecting. There is no movement. But if you measure the coordinates of something in your reference frame and see this happening, it moves. It follows these curvy shapes.
It absolutely does.
Yeah. So and it's because you don't understand relative motion. I mean, it's just.
It's absolutely following that path, and if you want to describe the path and not break Newtonian physics, you're going to have to include the force that goes along with it, or the acceleration. Absolutely. You've got to include that. It can't not be there.
And it's as that deflection, just as that video, that room that those people were throwing a ball to one another and it just shooting off to the side, that's as real a deflection as anything else. And from your point of view, there is an acceleration, i.e. a force, an inertial force. So It's actually an acceleration because I'm going to have to do a video on this because it's a reference frame issue, rotation, and therefore this is how gravity works as well. Just to complicate things again, it's an acceleration, and as you have force is equal to mass times acceleration, you multiply by the mass to get the force that it appears to be. Because if you wanted to stop it doing that, you would have to apply a force of that value of mass times acceleration. But what's actually being generated is an acceleration. The same is true of in Einstein's model of gravity. There's an acceleration being generated by a reference frame change. And that's why Einstein noticed that it must be like this, because he noticed things like inertial forces, like centrifugal force and other things, where you have an acceleration, and to get the force you multiply by the mass. He then realised that gravity was like that because it was independent of the mass. And things that are independent of mass tend to be due to reference frame changes. And that's exactly how Einstein's model of gravity works. You have an acceleration, and then it generates a force. This, of course, is what troubled Fight the Flat Earth when he was fighting Rachel on his channel. She was saying, where's the force then? And right, this is a classic thing, where's the force coming from? It's because the reference frame changes generates an acceleration, and then to get the force, you multiply by mass. So normally when we work in the real world, in our world, we tend to apply forces. If you kick something or punch something or hammer something, then you're generating a force, and that generates an acceleration. But when you've got reference frame changes, you're actually generating an acceleration, and if you want to find out the equivalent force, you then multiply by the mass. I don't know if I've gone a bit too far here and bored everybody or something, but there you go.
No, that's quite okay. That's exactly how it works. That's what's really going on.
Yeah. So gravity is generating an acceleration. I must admit, a few years ago, I was thinking it was more of a force thing. Then I read up on my general relativity book, and then realised it's actually generating an acceleration because it's a reference frame issue. And so, this is where you get the gravity is not a force thing. So if you read someone like Sean Carroll, who's a fantastic, I recommend anybody reading Sean Carroll, who did a book on general relativity, and he does say that gravity is not a force. What it is an acceleration it generates.
Yeah.
Which then generates a force, just like centrifugal force is an acceleration. If you want to work out what the forces involved, you multiply by the mass. Similarly with gravitation, you have in the Einstein model anyway, you start off with an acceleration, and to get the force that you want to know what's going on, you multiply by the mass. So when the Flat Earth was fighting Rachel, and she was saying, where's this force coming from? Well, it's a result of multiplying whatever mass you've got, because it's mass independent of the acceleration that all things are subjected to. This is why everything is subjected to the same acceleration, whether it's however massive it is. But if you want to work out the force, you consider the object, you've got an acceleration on the object, and you then work out by the forces acting on it just by multiplying by the mass of it. So it's mass independent. All objects will accelerate in the same way, because it's basically the reverse of the case of you hitting something and generating acceleration. You're starting off with an acceleration and you're generating a force.
And you can do the same thing with Newton's equations.
He expressed it as that there's a force was generated by gravitational fields. I mean, he doesn't think of it. So that's a bit different, I think. I think that would be a bit naughty.
Well, maybe slightly naughty, but I mean, you can eliminate one of the masses anytime you feel like it, and you've got an acceleration. You've got the acceleration attributable to any object you like, being simply the gravitational constant times that mass divided by the square of the distance to the surface of that mass, or the square of the distance to any other object, the center of it.
Right, but I mean, sorry.
So that way, Newton's equation becomes an acceleration too.
Yes, it becomes an acceleration, but it starts. The idea in Newton's thing is it starts off as a force.
Right.
The thing that's initiating thing is a force, and then from that you derive an acceleration. Whereas in Einstein's way of doing things, everything starts off as an acceleration due to reference frame changes, and then you get a force by multiplying by mass. So, for instance, the Newton way of thinking of it is like having a charge. You've got a positive charge on one thing and a negative one on another. Electrostatic is dependent on the field that's generated, and there's a force being created there, which then creates an acceleration. The Newtonian model is similar. You have a force between these two masses and it generates an acceleration. Whereas in the Einstein model, you have an acceleration and that generates a force. And that's what was causing the Flat Earth so much trouble with Rachel, who was asking some actually quite good questions, I thought, when they had the fight with her a couple of months ago. And the Flat Earth didn't quite give her the right answers, I didn't feel. But yeah.
Well, it all came straight out of, she was just reading the Sleeping Warrior playbook, yeah.
Yes, and he was just, and obviously he had an argument, who was he having an argument, that was right, he's having an argument with Gems. I don't know if you saw that, Sleeping Warrior put up a video recently of his argument with Gem Panda, and he kept on saying it's the medium doing the acceleration, and he was claiming that Gem was not recognising this, and it's not the way that. Well, it did actually have some validity, actually, because if you think of it, if the sun, which is obviously holding the Earth in orbit, if you removed the sun, the Earth, there'd still be a force on this Earth for 8 minutes, and it's actually the medium. You can think of it two ways. If you think of the gravitational field, is the thing that's obviously pulling the Earth, as Newton said, he understood there was a huge problem with this instantaneous thing. He said, do not attribute to me a means that there's a mechanism about how this is all happening. I've just got the equations that work, mate. And if you remove the sun, then it's actually the gravitational field from the Newton model that's actually holding the Earth in place. It's not the actual mass anymore. But it's a bit like saying I'm pulling on the end of a string. If I do the pulling on the string and the string's then pulling on the other object, it's actually the string at the other end that's actually doing the final pulling on the object at the other end. And if I had a string that was 100 miles long and then I was pulling on it and then I removed my hand, it would still take quite a long time before the tension of the string would still be pulling that object at the other end. So you can argue that the medium is indeed doing the work, and of course, that's the Newtonian gravitational field way of thinking of it. And of course, in the Einstein way, the space-time is still curved, and that's doing the work. And so this is where Jem got slightly troubled again, where the medium it's a bit just like a piece of string. You can remove the thing that's doing, but it's actually the final thing that has the effect on this final thing over a distance is actually the medium, whether it's space-time or the gravitational field, if you want to use the Newtonian model.
Yeah. Yep.
Right. In Einstein, the interaction is local to Earth, Doesn't matter what happened to the sun, it happens here, not there.
Yeah, I mean that's because you've got your own bit of space time that's bent and around Earth. So if the sun disappears, it takes 8 minutes or whatever for the space time to sort of flex back to its non-flexy state. So yes, but that's just like this. How's that different from what I was saying? The string is the same thing. If you're pulling on a piece of string to something, it's the string's contact with us. Say if there was a bit of string from the sun to the Earth. But obviously, the bit that's pulling on the Earth is the bit of string that's pulling on the Earth, and therefore, if the sun went away, it would take some time before the tension of the string disappeared.
Much longer time than.
I said the same thing you did, just in less words. The interaction is local.
Okay. But I thought you were sort of implying you adding to what I thought you were implying. You were something. Okay, all right. Yeah.
Yeah, if it was a string stretched out, that's going to take quite a while.
Yeah, but I think that's a good way. See, there's an example where I try and put it in those sorts of terms that some flatty can't really avoid understanding. Then, and that's what I try and do in exercises in my brain. This is why this is explained to flatties is actually an intellectual exercise for us. How well can you explain something that's compelling and impossible to argue against? And that's actually quite a challenge to do that. And I know, Blue, that you've found, I think, explaining things has enhanced your own understanding of things and improved your own explanation. Certainly, I know that George has gone through the same thing where he's found explaining things, he's become much better at it than he did originally. And so it's educational for us to interact with these flatties, is what I'm trying to say, as a justification.
Yeah, Jeremy, once I remember he was arguing that we told him that it will take time. If you push here, it will take time until the push will get there. Let's say if you had the road to the moon and you gave it a push, how long until the moon is going to feel it? It's actually something you can do. Test you can do.
Yeah.
Take something long enough and hammer it on the top and see how long it takes until it reaches the bottom. Let's say even distance of a meter.
Well, Jeronism did exactly that. He claimed as an invalidation of the gravitational model. He was saying if I had a pole, I think it was something invalidation of the speed of light. I think it was saying if I had a pole from us, I don't know, pushing on Jupiter or something or on the sun, I could hit that and it would immediately move the other object at the other end. He was arguing. No. That has rods do not provide instantaneous transmission of forces. Just they can't even manage it at the speed of light.
No, more like the speed of sound in that whatever that material is.
Absolutely correct, Blue. Yeah, you got it. Yeah.
Yeah. So if you start talking about that long pole reaching all the way to Jupiter, go ahead and give it a whack and come back about a year from now, or 2. Or 5 or 10.
Exactly.
Yeah. It's going to be a long damn time before your buddy on Jupiter hears that thing ring.
Yes. And this is, of course, to them, it was, hold on, I'm just used in real life, in my bedroom where I spend most of my life, these flatties are saying, when I hit something something solid one end, it immediately does it to the other end. And that's their thinking. They just take those sort of bedroom logic out into the big wide world.
That confuses a lot of people.
Yeah, it isn't obvious, I suppose. Yeah, Truth Nerd is being mean to me in the chat now.
Oh, really? What's he doing? That's okay.
Yeah, he's all
They're just picking on us a little bit.
Yeah, he's all picking. Yeah, so it's not obvious, is it? This is what all comes to this sort of in your bedroom type experiences, and when you do science, atoms. I do wonder that. Of course, there are quite a lot of flatties that deny atoms. Is it flat Earth? Not a flat Earth data. The other guy sounds like flat Earth data. He denies it, and oh god, and is it not Dyslow denies the existence of electrons and things. They just anything they can't see or experience in their bedroom, or hasn't rubbed up against their leg, they deny exists. So you can't use.
You're talking about right the hand.
Right the hand, that's it. Yeah, got it. Thanks.
Yeah, right the hand. Oh my god.
Yeah, he denies atoms. He denies forces. And Brenda had a debate with someone who I think might have been right the hand again, or someone fly. Yeah, something like. And of course they deny. Yeah, I think he also denies what accelerations are and things. I mean, this is just we're dealing with idiots. So yeah, so explain to them Coriolis is just unless you've got can get them in a room and tie them down in front of you for a few hours with lots of books and references to them. They. I mean, there was one guy I was arguing with about what they didn't understand that when you're gravity, when you're standing on the ground. I mean, Riley. Well, 2 years ago, I had to explain forces to Riley, and that if you're standing on a trapdoor, you're applying a gravitational force downwards, and the trapdoor, or whatever, is applying a force upwards. Hence, the net force on you is zero. And I can't remember now. There was something about. I said, well, what happens if the trapdoor then opens or the floor falls away? And he couldn't cope with that. I can't remember the exact. But basically, it comes down to they don't understand what net forces are all about. And some guy who on some bloody Discord thing I was on briefly, he didn't understand about indentations on the ground if you're standing on the ground. He claimed that's it, standing on weighing scales. He couldn't understand that the weighing scales were pressing down, the body of the weighing scales on the spring, and then you just adjusted that to be zero. And if you stood on the weighing scales and you added to it, he didn't understand the forces added. He said, where did the weight of the scales go? I mean, they don't even cope with adding of forces together. Oh my God, it's just.
You really want them to go and take a course in statics or something. Goddamn. I mean, it's not that hard, guys.
Well, it is for them.
Especially.
I mean, Jose, for instance, said he can't read anything for more than a few seconds. He actually said, "I'm happy with this," and that's why he makes so many stupid comments on his channel. And I got moving him a bit. He says, "I'm happy about not being able to read things," and so unfortunately, that's a Glober talking, a new ex-flat earther.
I did see Jose out in the chat a few minutes ago.
Oh, that's true.
He was out there. I don't know where he went to, though. I didn't get around to saying hi.
And I see Clive Wells has put in something about. Yes, he's allowed for these. He's got a quote here about the ballistics. Someone was disputing. I said yesterday that they had to allow for Coriolis. They were doing it in World War One when they were firing battleships then, and someone was claiming it didn't. And I then said that was a myth or a semi-myth. I wasn't quite sure about whether they went to the Falklands. There was a battle, the British Royal Navy and the Germans around the Falkland Islands in South America, and that there was a story that the Coriolis correction had not been allowed for the fact that in the Southern Hemisphere, and therefore we kept on missing. And other people have said this is a myth, but in fact, Clive Wells is has got a citation. In fact, there was a problem.
I think Druss, you know Druss, right? He had something to say about that it was a myth. I remember him saying something like that.
Right. Yeah, I mean, I've heard stories one way or the other, but Clive is offering documentation here that there was a problem. But either way, the point is the firing tables. I think someone was disputing yesterday that the firing tables for that they first invented for World War I battleships included Coriolis. They definitely do, or did. At least as far as my document knowledge goes. And I say Clive is providing evidence that there was some chap.
This account.
Falkland Islands issue.
Yeah, this account seems to support the idea that they forgot about opposite deflection in the southern hemisphere.
This reminds me of the story. I think it was an American fighter. I think it was in the 70s or something, where they had because it was starting to do fly-by-wire or something, and they went across the equator, and the aeroplane flipped upside down. And the pilot ejected. Said, "What the hell happened there? I went across the equator and it went upside down. It turned out the software hadn't allowed for the inversion of the coordinates or something, and then decided it would then all the flight controls went or negative or something, and then just decided it was being upside down was what it had to do."
Oh boy!
So yeah, it's not.
That'd be a problem.
So I don't know. I don't know whether there's another myth or something, but it sounds like the sort of thing a program would do. You're going to forget. Those bloody negative signs.
Yeah, damn it.
That's when you let flat earthers do the programming.
Yeah, I mean, anybody who's done any maths a lot, I think negative signs are the work of the devil. They just catch you out with brackets and things, and it's always more than anything else, I have a trouble with negative signs. Well, they just catch you out eventually.
Well, I don't think you're alone.
About.
I think it does it to all of us.
Yeah, I think so. I think George has also agreed with me. I think we all hate and I think actually was a PhD guy. I did a little maths test on Conspiracy Cat's channel about 6 months ago, and this PhD guy was saying, negative signs are things that make his life difficult as well.
Here were the files in the Coriolis I was looking for. Turns out they're GIFs and not MP4s. I thought they were movies.
Oh, there we go. Yeah, print stuff. Sure, yes. Yeah, so there you go.
It all depends on your reference frame.
Absolutely, and this is why we get these. And this is, I mean, it's actually, I mean, this is the fact that the weather systems do form circles. It's not absolutely obvious. There's an issue. What was the claim? It is a real deflection, but what's the flat Earth line on why it can't be down to? Damn it, I've forgotten it now.
They were confused on why hurricanes went the other way from the focal pendulum, and that's because hurricanes are a low pressure system. But
yes,
I remember Jeremy asking me that question. He tried to stump me on that. He said why hurricanes rotate a specific direction in the northern hemisphere. Then he asked me which way pendulums rotate. And I think it's in the opposite direction.
Right, because the hurricane is a low pressure system, and the pendulum basically, well, it's a sort of a high pressure system, sort of.
Yeah, and everything is trying to get to that lower pressure system. If an air molecule is in the north, it's going south, it's going to deviate to the left. It's traveling south.
Yes.
Wait a minute.
Am I right about that?
In the northern hemisphere, the deviation is always to the right.
It'll deviate.
Yeah, but if it's traveling south.
Yeah.
Is it going to deviate to the right as well? Okay.
Yeah. It'll do it. It'll deviate to the south too.
You'll lose.
Which is why you get that rotation. It's always the Coriolis is always shoving it off to the right, and but the high pressure is saying, "Oh no, you don't. You're going to the low pressure. I'm going to push you back that way," and it's got that necessitates a spin to the left, a counterclockwise spin.
Right. Okay.
Yeah, we should do we should do some proper. We should do you should have a proper video or a hangout just on that subject. Actually, we're going through the maths on it. That would shock them as to why. It's not immediately obvious to me what obviously there's a completely different thing, as you say. The hurricane's a low pressure system. You've got the pressure telling which way to go, and a pendulum is doing something different, which is going in its own plane. And the maths no doubt will show why those two things. They're not equivalent things going on, so they shouldn't necessarily. Right. Just because they're both Coriolis doesn't mean to say that you've got the same thing moving in the same direction, because it always acts at right angles to your movement, and then you've got to work out what is the original movement, and it just,
That's exactly right. Well, you've got two opposing forces. You've got Coriolis trying to make it do one thing, and you've got the pressure making it do something else. And pressure's going to win.
Well, I should say it's a perpendicular thing, isn't it? So I mean, the pressure is going to encourage a velocity in one direction, as we discussed yesterday. The Coriolis always acts at right angles to the direction, the velocity.
Yeah.
So it's trying to go in, and so it then adds. So there's a pressure. So there's a velocity towards the centre of your hurricane, and the Coriolis then says, "Well, I'm going to add to that a right angle force effect to that."
Right.
And then the sum obviously again gets you where it actually goes.
Yeah.
They're not in opposition in effect. What I'm saying, they are at right angles to one another. But if you look at the maths, they are fundamental. The Coriolis always acts to right angles to the velocity. And of course, if you're a flatter, you don't understand. You have to be moving. Someone like Nathan and QE think the Coriolis acts on something that's stationary. Hence, they think it's responsible for the stars rotating or the 15-degree drift they talk about. They think is Coriolis. No, it isn't. There's no velocity. You have to have a velocity in the non-inertial reference frame to have any Coriolis effect.
Yeah, if nothing moves, there is no effect.
Yeah. It's a cross product between the velocity actually, when I say the velocity, it's the differential of the radius, which, as I was saying yesterday, I was if you keep the radius constant, then you just have the velocity along the surface. But if you fiddle around with the radius as well as Chike was doing, then you have to allow for that as well. But if you're sticking with just the same elevation in effect over your sphere, then it is the same as the velocity along the surface, which of course is a curve, following a curve.
Yeah, Eric in the YouTube chat says the Coriolis effect is not an illusion. You are absolutely right, sir. It is not an illusion. It is very real.
Well, this one is one of my favorites recently. Tennis balls are flat.
It's amazing to understand what tangents are. I mean, Bev, for instance, doesn't understand what a tangent is. He doesn't understand the gradient of the tennis ball. The edge of the tennis ball is the same as a tangent. He doesn't understand that. No. He thinks of it in terms of the sort of Euclid type style of resting something up against the thing, not understanding the definition of a straight the line, the actual gradient of. He doesn't understand that curves have gradients, basically. I mean, just maddening.
Which leads them to the conclusion that you can't have an angle between a straight line and a curve.
Absolutely. I mean, it's just. So you
Which
need to
is
get.
ridiculous.
So when you explain these things, you need to go through basics like that before you've got. If they're disputing that level, you've got to find out how low you've got to go to pick up the person you're dealing with. Where are they having the first problem? And until you've found that out, this is why This is why my explanations are sometimes long. I try and pick up. I try and go to the lowest level of the explanation, then I see where the conflict point is, and then tackle that. But you've got to go really low sometimes to find the point where they're going to disagree with you.
Right. So ever since they came up with this, so we can't have an angle from a curved surface, that kind of gives us a way to test whether or not, like let's say for instance, okay, since we can't have a curve, an angle from a curved surface. Okay, so everything has to have a flat baseline. So that means if I make a straight line between myself and somebody, I don't know, in Florida, Jose, for instance, that means I can predict which angle the sun should be from Jose's location. And then when they say, oh, well, the sun is local to the surface of the Earth, I don't know when they say 3,000, 4,000 miles. Okay, that means if the sun is directly above me, it should be a specific angle from someone in Florida.
Yeah.
So I'll give them that. Okay, baseline, great idea. So let's test that.
Earth, why is your audio always so appalling?
Oh, you know what? Okay, it's probably because I'm using Bluetooth headphones, right. And I have the other side in my pocket, so that's probably why it sounds terrible.
Yeah, you all sound awful. It's very difficult, and you're half your words.
I apologize.
It'd be nice to hear you. I'm just selfish. I'd like to be able to hear what you're saying. That's all. And it's quite. I'm really having to work hard to hear it, to hear what you're saying.
Is that better?
Say some words.
Is that somewhat better?
Not really.
No. Okay.
It's not breaking up, but it's still muffled like crazy.
Oh.
But it wasn't breaking. It was less breaking up, less choppy than it was before. But it's just still as muffled. Anyway, I know I forgot what you were saying now. Damn it.
I was saying if we have to have a flat baseline.
Oh yeah.
For a triangle, I can make a triangle between the sun, myself, and someone else on Earth. And then we can predict from the other place, I can predict where the sun should be.
I mean, this flat baseline, like that Nathan Oakley and QE came up with, the fact that you can only measure something against a flat baseline because they don't understand you can measure against a tangent. I mean, for instance, and this is all irrelevant anyway, when you measure an angle to, say, the sun, if you do it with a sextant, you're actually measuring it against zenith. I mean, I suppose with the sextant you are measuring against the horizon. But I mean, other things like theodolites or what have you, they're measuring against vertical gravity. They're actually not measuring it against anything that's underneath them. And the idea that it's dependent on what you're standing on, the angle. I mean, their basic idea is if you're standing on a wobble, a little mountain or a hillock or something, or a lump of grass, Therefore, the sextant's going to stop working.
Well, they started up with this.
I mean, it's just so stupid. It's just unbelievable.
They started up with this, curve adjacent bullshit out of the sextant. I said, fine, then let's switch to a bubble sextant that measures against the horizontal, and you don't have to worry about the horizon. And they went crazy for a few days on that one.
Yeah, indeed, exactly right.
Well,
So that's not dependent on what you're standing on at all. Yeah, without.
Either way, it still they shoot themselves in the foot with the flat baseline thing.
Well, you only use the horizon on a ship because it's there. It's easy. I mean, it's a pretty good indication of your angle. And yeah, these guys, this whole flat baseline thing, as you said, just proves they don't understand geometry at all.
Incredible. Yeah, it comes from the fact that you don't understand. You can have a 10. Go ahead, Liz.
Yeah, because trigonometry doesn't stop working on flat Earth.
Well, trigonometry on flat Earth is quite interesting, actually, because then if you know the angle,
yeah, it is.
if you know the angle to the sun and you know your distance from the GP, you can figure out the
where the sun should be, right?
Yeah,
height,
the sun,
height,
and then,
yeah.
the height of the sun,
height of all the stars, yeah.
The height of all the stars, and that doesn't work out very good because then you start figuring out. Well, if you figure out at one, you use your baseline, say at 45 degrees, because that's easy to figure out. It just doesn't work out. If you go to
have you seen Brian's Logic's videos on this, in which he ends up drawing a box?
Oh, I try to stay away from Mr.
Yeah, I do as well. I'm not subscribed to him, but they're just other people. I think actually Blue has made some videos on him.
Although I will say he is the only flat earther who even attempted MC Toon's 10,000 buck thing. What he did basically is he solved it on the globe and then tried to backfill it with some sort of bullshit correction factor.
Isn't that what Brian did? I think Brian did that.
That was Brian. It wasn't Brian's Logic. That was Brian Leakey.
Oh, I got the wrong
Brian
Leakey,
mixed up? Yeah.
Oh, sorry, Brian's Logic. I was talking about Brian's Logic. So yeah, I was talking about Brian's Logic, not Brian Leakey.
Oh, okay. I'm getting the Brian's mixed up.
Yeah,
I get my Brian's mixed up. I get my Nathan's mixed up sometimes too.
Yeah, the stupid Irish one is Brian's Logic, and Brian. And as I say, he's got this box. He draws this box, and then when you ask him, I'm not barely had any chance to interact with him because I tried to explain to him on Skype about 2 years ago. I can't remember, was something so basic. Oh, that's right. He claimed that G was a velocity. Big G was a velocity. And I spent, I don't know, about an hour and a half with him on Skype, calling him a stupid wanker and saying, "How can you think that's a velocity?" I mean, I am a man of enormous patience, I believe. But I started off being quite reasonable, and eventually I just started. This is just, I'm getting to the point, even with my amazing powers of explanation, was failing to get through to him that this G cannot possibly be a velocity. Go ahead.
Did you report it? Did you record it, Rumpus, or no?
Did I report
that
what?
Conversation? I said, did you record that conversation with?
Oh no. It's probably. I suppose it's on my still on my Skype record. Yeah, I suppose it's there. Yes. Yeah, and at that point I thought this is the same guy who claims, of course, you get this optical drop thing when in geometrically it's impossible. And I went through that, spent an hour and a half on that. I just thought, I'm used to. People might not believe it, but I think in comparison to a lot of people, I've actually prepared to put up with quite a lot of length of time I'm prepared to put into these people. But that was just too much for me. The G not being a velocity and him not, and then him getting mixed up between little G and big G, and then claiming it was a velocity. And I think Blue did a good video on this. I mean, that just blew my mind.
Well, the main thing that these guys forget is that one of the first things they teach you in Physics 101 is unit analysis. You got to solve so that the units make sense.
That's right.
And these guys forget that, and I guess Travis.
I don't think you even need to go into that. I mean, you can just say G is not a velocity. I mean, you can describe all these bits of the equation. I mean, you could do with the unit analysis, but I think that's probably a bit advanced for you. You don't need to go into any of that. He just thought that it was. Now, what's his reasoning for? Because I think G's an acceleration. Little G.
Big G's units are what? Something
weird. They're very
Newton,
weird. Yeah, acceleration.
Newton meter squared per kilogram squared.
Yeah.
And I didn't go down that road because if he's just going to say you've done some tricky maths on me. But
the other guy who does this a lot is Travis. He'll come up with some numbers, and I try to pin him down on the units, and the units just don't make any sense at all. But he comes up with the number that's approximately the number that he wants.
And then, of course, we've also got that amazing thing that Fed used to do about the distance to something. He was using the Rayleigh criteria, which has a square root of whatever it is, of something of whatever the constant is in the Rayleigh criteria is very similar to the same ones used in the distance to the horizon. He somehow then said, well, we've got two numbers here that are very similar, therefore they're dealing with the same thing. The Rayleigh criteria, therefore, is giving you the horizon thing. And I think actually Blue did a video on that as well. God, bloody hell, Blue. Very, yeah, I mean, these people, it's just...
Yeah, that constant is, that's a Bessel function, basically.
Yes. Yeah, it's a second Bessel function, I think.
First, I think.
First order? Okay.
Yeah.
I read up on it. It's a lot more complex than Lemon thinks it is.
Well, it's that Bessel function at the first minimum divided by pi. Yeah.
Holy shit! They found a C-wreck. They found the deepest known C-wreck now is Samuel B. Roberts.
Oh, really?
Let's see how deep. 22,601 feet. That's 6,895 meters for you, Columbus.
Wow.
What is that?
They found it. They found the world's deepest known wreck. It's at 22,000 feet in the Philippine Sea.
A submarine wreck?
No,
it's a destroyer.
The destroyer of World War II.
Yeah.
Oh, right.
Very famous battle in the Philippine Sea.
Mm-hmm.
The captain was awarded the Medal of Honor from memory.
You know more about that, I do. Anyway, it's way down there.
Kelly D in the YouTube chat asked me if I would consider building a Foucault pendulum. Odd that you should bring that up.
I've been trying to get you that for a while.
The other day, I had nothing else going on, and I rummaging around, and I saw one of those little 780-gram lead balls I had left over from Cavendish. And I thought, well, why not? I'll just play with this thing. What have I got that I could use for a line to attach it? And I found some stainless steel wire. So I wrapped that around a piece of conduit that goes between two of my fluorescent lights out there in the shop. Set the thing in motion, and then I discovered metal fatigue. And thoroughly proved that concept. It swung about 10 times and then fell to the floor. So I believe I'm going to have to improve my method of attachment a bit. But yeah, I'm seriously thinking about doing that.
I was thinking about doing that too, because I have a warehouse with a pretty high ceiling where they have like rafters.
Yeah.
Probably about a good 20 feet up. And I was thinking about trying that before I get out of here.
Yeah, the pivot's the hard part.
What I hadn't gotten around to
You need
yet.
You need a low friction pivot that doesn't stress the wire, as you found out, Blue.
Right, yeah. I thought that would happen eventually, but I didn't think it would happen that quickly.
Yeah.
Anyway.
I was just going to use like a 550 cord.
I think I'm just going to go rummage around somewhere in some of my old fishing stuff and see if I can't find a piece of fishing line and use that. It won't.
That'll probably be better than it'll certainly handle the fatigue much better than stainless.
Right.
Stainless fatigues quite easily. You'd probably be better off with a piece of mild steel fencing wire if you can't find anything else.
Well, actually, I've got some copper wire that would probably be softer on copper.
Okay.
That might work.
Be careful if you're using braided wire. You might introduce a bias as this thing spins.
Yeah.
Yeah, and that's why I was trying to use solid material of some sort. But, with a little tiny weight like that, I wanted to keep the diameter of it as small as possible.
Just monofilament fishing line.
Because the damping effect, is friction in the element that plus air resistance.
Yeah.
So.
Yeah, it's sad because you want it really long, and the longer it is, the more you're fighting.
Yeah.
All right, you want it long, you want it heavy, and yeah, I've been trying to get you that for a couple of years, Blue. That, and I think you should do the Michelson Morley.
I mean, if the ball is heavy enough, then you can obviously you compensate for the drag on the long wire. If you can make the ball really chunky,
right?
Heavy.
Well, I saw these guys doing it with a bunch of sandbags and a rope on an overpass on a bridge. You know, the bridge was like 80 feet up, and they were doing it from just hanging a rope over the overpass.
Yeah, I saw that. That was they were like Spanish, right? They were like speaking Spanish.
Yeah, it worked amazingly better than I thought it would.
It worked.
The parking garage stairwell. That's just the place to do it.
And probably never used, or some office building, a big tall office building with an emergency staircase that nobody ever uses.
Yeah, any enclosed, circular stair, fire exit like which would be in a parking garage because they all have elevators.
Well, if it gets just a slot, you can do it for a while until it runs into the slot. But
I'm gonna go around the back.
Yeah, but anyway, I'm going to work on that, come up with something, or I'm going to keep playing around and just see what happens.
Have they got your Cavendish working again yet, Blue?
No, not yet. I haven't checked with them in the last couple of weeks to see how the remodel is going.
How did they improve? What did they do to get a better, improved measurement over yours?
I think it's just because it was... it's in a better environment than it was in here. Not that it was in a bad one. It was perfectly suitable for what I was doing, but occasionally my HVAC system isn't perfect.
Yeah, what was their
either.
data collection method?
Huh?
What was their data collection method?
They did the same thing I did. They learned from me, and they got tracker software, and then just time lapsed the laser, and if you do that, you can get really nice, accurate.
You don't think that these young science students managed to do a little bit better than the old guy?
To this point, they haven't. But give them a minute. Let them think about it. They'll come up with. I'm sure they'll come up with something.
Well, they might be just slightly. The guys are a little better or something.
Okay, that's quite good. I mean, it's quite good play that they haven't. They're just not doing anything. There's nothing. Nothing about the method that they can do immediately to get a better result than the one you got. So interesting.
Yeah, it was. It wasn't remarkably better, but it was. I got around 0.6% off. They're about 0.5%. So it was better, definitely.
0.6%. That's pretty good. I think that's.
Not bad for something you conjured up in your garage, huh?
Well,
not bad. Especially not bad since it's one of the hardest constants in physics to observe.
That's right.
What was Cavendish in his original experiment? How far was he off?
About 1%.
About 1%.
Ooh.
That's all I was trying to do. I just thought if I could get close to what Cavendish did, I was going to be happy.
Definitely.
It shocked me that I got as close as I did.
Yeah, no, I think
which made me.
Blue. I think it's good stuff.
Yeah, by projecting onto the wall, you get that magnification, and then the video data collection. Yeah, you had a lot of technical help over him. If he was just reading that vernier off one end, man, that is tough.
That is super tough.
Hello, I'm Neil.
I did it. Hey, Jose, what are you doing?
I just need 30 seconds to give a big shout out to you. Thank you for providing the platform for us to hang out. I've been lurking in the background. I want to say hello to an important person in the chat box, Dan the Waterman. Shout out to Dan the Waterman. He say he have measured things. And I want to remind you, the audience, everybody, Dan the Waterman was involved when 3 years ago in the Salton Sea, an event happened that the curvature was measured. A lot of flat earthers went in and zoomed in with cameras and did all kinds of good stuff, right? Well, Dan the Waterman was present. He said, I measured in the Salton Sea. Well, what he did was cook hot dogs for the crowd, for the flatties friends. Maybe he cooked some hamburgers. Who knows? Definitely hot dogs. So, Dan the Waterman, shut your pie hole when you say you measure things. Maybe you measure the distance between hot dogs in the grill. Thank you very much, Blue. I'm out of here. Boom.
Measured how much ketchup you put on the hot dogs, huh?
Thanks, Jose. Nah, Dan, we're not going to do that. Come on, man. Don't be typing stuff like that. What were we yapping about? Oh, yeah. But back to UT. They were running those. They were avoiding running it when anybody was around. They were doing it on nights and weekends and stuff. So they didn't have to worry about somebody being close to it or anything like that. They pretty much just set the camera up, moved the weights, and then got the hell out of the room and left it alone. So they've got a little better situation than what I had. Occasionally I had to open my garage door, and once in a while I had to walk around in there. So that's always a potential source of random error that you really can't account for, other than just to make a note of it in the book, But yeah, it's quite possible to duplicate what Cavendish did. But back to what Larry was saying, yeah, I did one complete test where I didn't do anything but sit there and stare at that damn vernier. That's torturous. Cannot.
Cavendish was an interesting dude.
He was a bit weird.
That's the understatement of the day. How long did Cavendish take to do his experiment, Blue? Over what period of time?
It's not well documented exactly what period of time that all of that took place over. But he did 28, I believe 28 different tests. And I can't imagine he tried doing those more frequently than, every day or two. He was fighting weather and all that stuff.
I bet he spent a year.
Yeah. I wouldn't be surprised. I did 48 total, 46, 48, I think.
But you were.
And his time standard would have been a little tough.
Oh yeah. And that has a huge effect. If you miss the oscillation period.
You take off, a 0.1 hertz off it, and it's all different, right?
Well, I did the numbers. I happen to know these numbers because I've done them. If you miss the oscillation period by 2 seconds, and you misposition the large masses by 1 millimeter, just those two arrows will throw the measurement of G off by 1%.
Wow.
So he would have really struggled to get that sort of time precision.
Yeah.
1 millimeter, bloody hell.
Yeah, that's all you got to do is misposition those weights by 1 millimeter and miss your time by 2 seconds.
And what year was that Cavendish did it?
1798.
Yeah. Oh, so the meter was, I didn't know if the meter was around yet.
And then you think someone like Riley or that Dr. John Dee, whatever it was, their idea of doing Cavendish was one was in a bucket or whatever, and the other guy didn't even have it on a torsion wire. I mean, the scale of difference between what they did and what you have to do is just enormous. Oh.
Yeah, it became immediately obvious to the casual observer that those two clowns didn't understand the problem.
It's like PNS said a couple of minutes ago. Units. They had no idea that they were dealing with micronewtons or nanonewtons.
Nanonewtons.
I don't even know what that is. That's just gibberish to them.
It's those small numbers again.
Of course,
the word Newton as a force unit, totally lost.
Well, when I was speaking to Riley before I blocked him on Skype, he didn't understand what force was, and until about 2 years ago when I explained it to him about this boards and holding you up, and so he didn't even understand what newtons were, and that was a measure of force. He didn't really understand the difference between mass and force, and it denied. I can't remember. He denied that it was so basic that he didn't understand that a force was required to generate an acceleration. I mean, so these are the guys, obviously. You can argue the fact that he just put something in a bucket is about, almost as much as you could expect from someone who didn't understand what a force was until a year or so ago.
But to be fair, you could go a long period of time and never encounter a Newton, and kilograms have been substituted for weight far, far too long. Unless you're measuring diamonds or gold bullion, you don't know.
Yeah, I mean...
To be fair.
Yeah, I mean, it's always confusing when you say the scales are showing you your mass, and of course what they actually do is measure a force and then convert that into a mass by effectively dividing by g. But of course they say, well, hold on, this is a force. And of course they don't understand that a bloody scales are force meters for a start. I mean, it's just... oh.
Yeah. That is a fact. They do not.
And of course, if they're threatened with any mass, I mean, I keep one of my classic questions is asking: can they work out how long it would take a mass to fall 10 meters? If you dropped it at 10 meters high, how long would it take to get to the ground? And I don't think I've yet found a flat earther that can do that calculation. Though I think looked it up on the internet, they used a calculator. But other than that, I don't think I've met a flatty that could do that calculation. And you've got to bear that in mind whenever you're dealing with these people, that they are ignorant of basic maths and basic physics. And then you get QE telling about reference frames and Coriolis forces, and they start talking about quantum physics at you. Jesus Christ.
Yeah, I think we might be better off if we tried to master the fundamentals first. I know they're dying to tackle the problem of dark matter and dark energy, but maybe we ought to work on gravity.
Yeah, I mean, gravity's complicated enough for us. I mean, for Christ's sake.
Yes. Yeah, we're still scratching our heads a bit on that. So.
Yeah, and they always abort to we don't know the cause. It's that outside the discussion. It's the natural, the Newtonian laws are the observation of what it does. It doesn't, we don't know what stars are. We don't care. We just see them, and we know they're far away. And, we don't know. And therefore, everything is wrong. Everything is unknowable unless you have, fringe theoretical physics figured out.
Yeah, they love their ignorance, don't they? And I think, as I say, they use this as a weapon by rejecting learning things and by claiming everything's unknown. Then they can just say, I wish to believe in this. So your own wishful thinking then becomes the primary source of your information, not your knowledge. So if you keep your knowledge to a minimum and your logic to a minimum, then you can just let your wishful desires to do the work for you.
It's just a dodge. It's just a dodge that, gravitation is well known. That is one of the most well-known things we got going. Gravity, that's different. We don't measure gravity, we measure gravitation. Okay? Granted. Oh, but black holes. Fuck off.
I'm listening to them babbling about red shift and blue shift the other day. That was funny. How do you know? Well, we got a star that's right in the middle of our damn solar system, you idiots. We can point at...
And we got Mercury. Yeah, we got Mercury and Venus passing in front of them. It ain't 3,000 miles away. No. And once you get over 50 million, I don't care anymore. That's far enough.
But you can point a spectrometer at our sun, and it's passing through the same damn atmosphere that the starlight passes through, you stupid shits. So yes, we have a light spectra that we can compare to. It comes from our sun.
Have you seen QE's spectroscopy lectures that he gives? I mean, he completely gets that wrong in terms of the absorption and the spectral radiation in the bands, and he doesn't understand how it's moderately complicated, but if you've seen it, even something which he's read, they can't understand even the stuff they're reading. And of course, we know this from QE, that every single citation that he ever offers, you can guarantee that the next paragraph also, as Bob Sartzguy has documented superbly, that he then contradicts him. At the very least, sometimes it's slightly ambiguous, but 95% of the time there's a contradiction of whatever point he's trying to make.
I don't bother looking for another source to debunk him. I just use his.
Yes, exactly. It's self-refuting. It's great, isn't it? Just go to the same thing he goes to.
Yeah. Yeah, he makes it easy.
He's
for sure.
Down.
Huh?
Yeah, because that's exactly the case with the spectroscopy one. He's in the spectroscopy thing. He gives a citation for this effect. I can't remember now what his point is. Now that you can't. That's right. Of course, he claims the sun is a black body, and therefore, how can you bounce stuff off it? And of course, the point is you bounce stuff off the non-black body element of it. The parts of the sun is not a perfect black body. Certain frequencies are reflected, others are not. It's just mostly a black body. And what was that?
Yeah, but radar ranging to the sun is so unnecessary. It's just not necessary unless you could refine things a little bit, but it's just, who cares? It's 93 million. I don't care.
It's just nice to. Well, it's nice to do it, though, isn't it? It makes them something. You see, all that stuff you're talking about, the 93 million, that involves a lot of, moderately complicated sort of trig and things. Whereas if you tell them that it's basically radar, then they tend to accept that more readily. I'm bouncing light off it, and I just need to take the time. And then, of course, you get idiots like Brian's stupid Irish logic, which says that you need the two-way speed of light or something. When you don't really, we don't have no reason to believe that just because you can't measure the one-way speed of light, that it's any different from the two-way speed of light. We've no evidence to suggest that, and everything we've got suggested it isn't. And then, of course, you get idiots like Brian's logic then trying to claim without knowing that for sure. Then you can't do these calculations to the sun. Oh.
Yeah, when they say we only know the one-way speed of light, he goes, which way is that? Coming or going?
Well, we know the two-way speed of light, and they claim we only know the two-way speed of light. They claim that you could. In other words, the idea is that it could be taking an awfully long time. It could be almost instantaneous to get to the sun, but take a long time to get back, and the average is then what we call the speed of light. But it's just because we can't measure it doesn't mean to say that there's a problem.
But the point is, does light coming from Sirius approach us faster than the light coming from Vega? In other words, which direction is the way? If you send it outbound, it hits a mirror and comes back. Okay, now rotate, move your detector to the other end, and then does some things change? In other words, which is the preferred direction?
Yes, obviously we've never found a preferred direction, and when you do these tests to measure the speed of light, they're pointing the equipment in all sorts of directions to measure this two-way,
like I said, does light coming from the sun have one speed, and when it hits the moon and then approaches us, is that change? Off the full moon? Well, now the sun, that light is reversing direction. Does it change speed? No, it doesn't.
Yeah, it's just an arbitrary. It's just a sort of philosophical point that Einstein pointed out, that actually to work out the speed, you have to take an average of the two-way thing, and so just because it's difficult to measure doesn't mean to say that it's causing a problem. We've never had any suggestion that it causes a problem. But those the sort. That's how desperate you are. You can then start, almost go to the point of, we're not living in a real universe or something. Another level of argument. But that's effectively, and of course with Brian, with his box shapes. He believes that you can only make measurements on a flat Earth, these angles to stars, and as we were pointing, as it paid NASA Shillen, and we were talking earlier, these boxes he's got, you can work out the heights to the stars anyway, which of course are all completely wrong.
No, that's because you don't understand sky morals.
That again?
I said that's because you don't understand sky moils, or however it is.
Right. Oh, of course, this is the guy who came up. What was it? He claimed that degrees were. What was his claim? Brian's logic claimed that degrees.
What was it?
Were velocity or something. I can't remember now what he was claiming. Oh, there was some extraordinary claim about.
Oh, is that the guy who wanted a section of arc, and someone mentioned seconds? of arc?
Yes, that's it. That's right. Yes, he thinks that. Oh Jesus!
You never heard of the angular unit of seconds. Seconds, and therefore he said, well, that's time. Why are you bringing time into it?
That was Riley. That was Riley. That's right. Riley heard the words phrase seconds, and I think also Brand's logic thought this originally. Yeah, they thought this seconds, and therefore they thought that was a time. Yeah, Jesus Christ. Like, they just don't realise how stupid they are. I mean, they're too stupid and too ignorant to know how stupid and ignorant they are. It's just... I mean... Whereas we know we're pretty stupid and ignorant. We know very little about, there's so much to know. And Blue was talking about Bessel functions earlier, and Clive Wells uses Bessel functions, but I'm sure even he, as a Bessel function master, thinks, there's an awful lot of stuff I don't understand. Whereas they with their Dunning-Kruger confidence think, oh yeah, that's easy. Flat Earth angle to that, therefore, yeah, that's sorted. Can't have an Earth angle to a curve, therefore, Jesus.
Yeah, Navigator minutes. Clive's pointing that out in the chat. Yeah.
That was it. Thank you, Truth Nerds. Navigator's minutes. That was it. Oh, God, yeah. Oh, Jesus Christ. Just extraordinary. With absolute confidence, it's delivered.
Yeah. Well,
I don't know. I'm sure Blue's the same, but when I've talked this to George Communications, when you think of something and you think, this seems a bit odd, before I come up and pontificate about something, you go and check it yourself. You test what you think a couple of ways to make sure what you think is relative likely to be correct. Whereas these people just launch at their first wishful thinking, and that's it. They never have any self-critical analysis at all. Just go for it, mate. Dunning-Kruger provides you with everything you need to know.
Yeah, I honestly feel sorry for Brian's logic. The guy is camped out over there at Nathan Oakley so long, and every time he does one of these goofy things, they all pat him on the back and tell him what a great job he's done and how smart he is, and he's started believing it.
Yes.
They're not doing the man any favors. That is a fact.
Little Brand's logic. What was that little thing he was trying to do? He was trying to show the Earth was local with that little model he made in his garden with all those lines. And he was actually trying to do something geometric to show that the Earth was local, Sun was local. I can't remember what it was now, but there was actually a sort of basic idea of correctness about it. Although obviously it only requires one error, of course, to go completely screwy. But at least he was trying. Whereas Brand's logic just. See, well, I suppose he has done those experiments.
It's really tough to build a model that's going to do all the math for you when you're working at like 400 million to 1 scale.
Do you remember the Ranty? Was it just before he became stopped his channel? He was trying to do a model of the Earth, Sun, and Moon together, and in his garden, and he managed to get every one of the ratios wrong, I think, except for the relative size of the Earth. No, I think he got the Earth and the Moon wrong size. Of all the things you've got to get right, you've got to get all the ratios of all the distances correct. And he managed to get all of those wrong. And the only thing he got, of all the things, I think of the 6 or 7 things you need to get right as ratios, he only got one of them right. And then with absolute confidence, he was then declaring how, eclipses can't work, etc. I suppose if you're a bit stupid and you can't work these things out, then I suppose you just can't do it, and that's what's really problematic. And then you dismiss it as all being magic.
Yeah, they're good at that, though. They're really good.
Oh, that's right. There's other. I don't know if you saw. I saw an Everett Anderson thing with Jem Pounder fighting with Dell from Glasgow. It was on loaded today, and Dell was eventually ended up threatening Jem, beating him up, and he was claiming that you can't have a model unless it's actually made of the real stuff of the thing you're modelling. In other words, a model of the Earth, your globe doesn't count. Because it's made out of plastic, even though you're only trying to model the geometry of it. Oh no, it was not made of bloody Earth, is it? It's not made of the same stuff. No, but no model is, you moron. No model ever has the same constituency. If you're worried about the geometry, you just build a geometric model. If you're worried about substance, well, actually, I don't think anybody bothers to make a model of substance scale down, because you always get problems of different scale factor problems if you're trying to do that. I mean, even when they're trying to build models of water flow and things, they have problems doing that accurately with fluid dynamics and sand and God knows what. You can't reduce that properly. But anyway, his claim was that you had no scale model of the Earth, no globe model or anything like that. It's a geometric model, doesn't count because it's not made of the same stuff as the Earth. Oh.
Why? Dimok said that plastic is gravity.
He said it's gravity.
Yeah, he said something. You take your globe, the plastic globe, it's gravity. Something in that spirit.
Yeah, I mean, this is the other classic thing, of course, is they don't understand anything to do with scale, of course, completely screws them. So this is why we've got this, how can you have gas pressure without a container? Not realising, of course, something about mass and gravity. Unfortunately, you can't model that. You cannot have a little black hole in your laboratory and model the Earth, because we've yet to find a means of modelling mass in smaller, reducing it and then getting extra mass. Unfortunately, the only time you're going to get these effects of dragging molecules and things towards something is when it's as big as the Earth, and we cannot reduce that in size. You can't model that, but of course that's beyond them. So there's anything to do with obviously that gravitational force we cannot reduce in size, and so that obviously catches them out like crazy. Oh,
well, it provides them a convenient excuse.
Yeah.
And they love using it.
They do.
Yeah, show me water sticking to a ball. Okay, buy me a ticket to the ISS, and maybe I can do that.
Yeah, scale is one of the biggest problems they have, isn't it? Anything to do with a big difference in scale, and that's it. They're completely lost.
Yeah, yes. Kitchen table stuff, which is not an analog for the Earth, but yeah, they're looking across something that's in the neighborhood of 10 feet, 12 feet, and they go, oh, look at the 25,000 miles that I've just disproved. I made the South Pole go away in my kitchen.
The classic one, Dell tried to work out whether or not the curvature of the water was curved, and to establish this, he got a fish tank filled it with water and then measured with a ruler the two different ends from the middle and said, look, it's not curved. It's the same end at one and the other. There we go. I've proved it's not curved, mate.
Well, yeah, well, he had to measure the center as well.
Oh, this is why you've got to show these people with diagrams, and you've just not got to let them get away with anything. Oh,
yeah, you're going to
too difficult.
Take a plastic drugstore ruler and try to measure millionths of an inch with it.
Exactly, and this is the guy, of course, who claims there's no such thing as a pulling force. Don't know if you're familiar with that, Blue. He claims when you pull it, you are from that. So he did things that when you say, well, hold on, I can pull a door handle open. Apparently that doesn't work for him. But your tension in a rope apparently doesn't exist.
You're pushing on the backside of the door handle, right? You're not pulling it.
Yeah, something like that. Yeah. Yes, you're pushing on the back, even though there's tension in the rope that you're doing to pull it with. That doesn't work. And then he threatened up because Jem was saying you eventually he initially swore at Jem, then Jem swore back at him. They said, if you did that to me, mate, in real life, I'd bloody kill you, or something worse to that effect, and beat you up or hit you in the face or something. That really is a malicious flatty.
Yeah, Dell's a special case.
They're socially dysfunctional. Sorry, they're socially dysfunctional as well as intellectually dysfunctional. I've never yet met I can't think of any. There's just a couple of moderately nice flat earthers that I've come across. They seem to have social problems as well.
I see G.G. Little in here and Eric E's in here. They've been sitting very quietly. You guys got anything to say?
Oh, not much.
Hey, jump
Eric's
in.
busily providing everybody with bloody. He must have the biggest library, online library, than anybody. He keeps on coming up with this stuff. I'm still reading that book. I'm trying to read that book, Eric. You provided me this on Coriolis. Eric's the man to know if you want to get a reference to an old book or so.
Oh, you betcha.
Yeah, he's helping me out with Rect actually. Eric has I've done some plots of temperature things and using Excel to show the the vertical temperature gradients, and I wanted to present those in Excel spreadsheet and all sorts of various formatting things, and Eric was helping me out there. So he gets a credit for RECT, my Earth curvature test thing on the Bedford levels. He was helping me out there. And also looking up about 3,000 references on refraction, which will be an issue when I get around to doing it. We need to get this refraction sorted. But as Larry knows, we know that we can account for refraction because we built buildings and all sorts of things. Because that's the Chris Berry got onto me the other day. Said, "Where have you been?" And I said, "I'm doing this. We'll be doing this RECT thing shortly." And I said, and I mentioned to him I was doing optically. He said, "Oh, well, you've got refraction then. That means it's all wacky and can't rely on it." Well, I'm afraid the people, surveyors and things, and architects and builders and things have used things that were allowed for refraction for many hundreds of years and got it all right and it all works. So I think we can manage to allow for it in the observation in RECT.
Yeah, if you come up with 4,700 mile radius, that'd be great.
Yes, indeed. I'm gonna have to. Yes, I'm gonna try. I'm gonna be giving a red value for the radius. If of course there is a drop, I will be coming up calculating a value for the radius of the Earth, allowing for refraction, and that'll be interesting to see how close it is to the real figure or the accepted figure.
Yeah, well, the refraction value is, without refraction compensation, you'll get 4,700.
Right. Okay.
So if you get 4,700, you're good.
Right. Assuming I'm assuming I'm gonna get standard refraction in those conditions. I mean, it's if it's a normal day, and I'll be doing it through. I mean, I have done observations and seen things moving around during the day when I did have a chance to get some observations in, and so I know that things during the day, and as we know, and as George knows from his own personal observations, are doing a daily odd thing, and if you look at papers on the subject, and it's even in surveying books they talk about this. That in the evening, the refraction often you get very large, substantial amounts of looming in the evenings, and in the mornings you get some as well, but largely in the evenings.
Right there in the Ordnance Survey textbook, they say midday, suffer the scintillation. Twilight ain't going to happen because after about 3 in the afternoon, you're done, and before 10 in the morning, don't bother.
Yeah. Indeed.
Now, when I measure a vertical angle at 15 to 18 miles, I spend about 45 minutes. And in that 45 minutes, I'll have observed it, like 12, 14, 16 times in both faces. So that's like 36 pointings. And I can see a maximum and a minimum. I can watch it go up and down. So I'll read it and then flip it around, read it again. I go, well, that one's a little bit higher. Oh, that one's a little bit higher. Oh, wait, a little bit higher. And then now it's going lower, 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 lower. Oh, and back up, and lower, lower, lower. Plot it out, bell curve.
All right. So you have done over a period of a whole day. Then you've seen how the
No, 45 minutes.
Over 45. Bloody hell! Right.
No, it takes 45 minutes. It's a procedure. There's a lot of knobs to turn, and you need the repetition. And by that repetition, you get a time span. And I was noticing maximums and minimums. So I would say, we have a new record low, and then I keep measuring. Oh, we're going back up. And I found, so when I see those maximum minima, then it kind of tells me now the average. If I just, if you just point, read, and go home, you don't know what you got. And over 45 minutes, now there's a big sampling of the air, and I could watch it go up and down. Now, keep in mind, I'm only talking about two times the width of the crosshair.
Right. Have you ever tried to observe what the refraction effects, how they change over a period of a day?
Nope. Don't know. Okay. Don't care. Because
I mean that's what I say. This paper that I particularly referenced, and also Eric also found. I found it about a couple of years, and one that's very popular, and also Eric when he was helping me out.
I've seen reports. I've seen reports where they did it every 15 minutes for 24 hours.
Yeah,
okay?
Exactly. That's the one. Yeah.
They did it. I don't have to.
Indeed, exactly. It's not something you'll be interested in because it does not. You'd avoid those situations. But they were doing.
It has to have a point. It has a bottom line, and I was going for volume. I mean, 40 or 50 more of these points to go do. I'm not going to spend. I can't spend a day each. Why would I do that?
Yeah, I mean, exactly. This is just research into the phenomena of refraction. Obviously, you're much more interested in actually getting some results that are useful. Yeah, so these people did that, and they showed that, as I say, in the evening, that you get this very substantial increase in the refraction.
Which, if you notice, black swan, the sun is very low in the horizon.
Indeed, in the evening, yeah, exactly right.
That's the worst case scenario. Absolutely. I hear all kinds of people say, "Oh, in the morning when refraction is low, scintillation might be low, but refraction is high."
Exactly. And you see most of those images you ever see, and what are called circulating rays, when the curvature of the light matches the radius of the Earth, they're called circulating rays, and that means that the Earth will look flat, and that's exactly what happens in the black swan situation. And that happens on this paper that I was looking at. That actually happens they did a 4 or 5 days, I think, observation, and every time at about 6, 7 in the evening, you got into that circulating ray situation. So it's not actually that as uncommon as you might think. But at that point, the Earth will look flat if you take it then. But as Larry says, yes, not when the surveyor's going to make their measurement. They're going to avoid that like the plague.
Well, Jesse recently did observation when he measured the horizon to be above eye level, but he said, I don't know, he waited for 8 years.
Yeah. And George got one measurement. George did an observation every day for 6 months, and he got one occasion when the horizon rose above horizontal. It does happen.
Yeah,
that was winter time over ice in the morning or something.
Yeah, correct. That's right. Over ice. It's more common over ice, indeed.
I think it's the only one Rocky ever puts out too.
Yeah.
Constantly posts that one.
It's just fantastic to see that because Ranty, I don't know if people remember, Ranty's favourite phrase was "show me looming, show me something rising above something in the foreground," and then of course there's George then goes and gets this very thing where the lake, you couldn't see this far lake, there's an island, and the distant lake you can't see normally, and then he got this actually thing to rise up to the point you could see beyond the horizon, and it actually loomed up above what was usually the horizon. And so George actually got photographic evidence, and I've incorporated in a document, which one day I'm going to publish this in a bloody book stroke thing on refraction. So it does happen. And those are the situations, of course, where people like Larry and Jesse are going to keep well clear of it. They don't, otherwise their building will be wrong.
Yeah, there's certain places that are just prone to that sort of thing happening. And that area out there where they take that picture of the black swan is one of them.
And even he only gets it. Was it one in? He said he only got one of those every 30 visits or something. He got those black swan images.
I forgot what he said now. But
something like that.
Certainly not an everyday thing. It's
incredibly unlikely even for him, but he does get them. But but even for him, they're still unusual.
Yeah.
That's right. No, that thing. I didn't see how much you covered. I missed the first 20 minutes. Your covering of QE's thing yesterday, and he was saying, which included the black swan, is saying, how do you account for? He seemed to think it was rather weird. You've got the two images of the black swan, the oil rigs, one in which is normal conditions and one in the black swan image, and then he was saying that somehow this invalidates. How do you account for this? As though this is somehow a problem. Well, the refraction. I mean, what is the problem with you? How can you? And then claiming that we think this should be equating to an expanding or retracting Earth or something. And that, I mean, that thinking is just beyond me. This guy's so stupid. He doesn't understand if refraction's varying, it can cause the change in behaviour. What else does he think it is?
Right.
Oh.
Yeah, it doesn't prove anything except that the atmosphere is variable. It doesn't prove a thing except that is one piss poor way of trying to figure out what the radius of the Earth is.
Absolutely, your way with the Aristosthenes is much better because of course he done this guy, the WMS 69, BLMS 69, whatever it's called. He deliberately got down within about 3 feet of the surface of the water, where he was right in the area which is going to have maximum black swan circular ray type effects. If he got up, I think actually on that same day with the black swan, I can't remember now, but I think on the same day he then went up to 30 feet.
Yeah,
as well, and took a picture there, and he didn't get the effect.
Actually,
So
he's still got the effect up there, but not nearly as badly
same
as
degree.
it was. Yeah, right.
Yes. So in other
Jesse
words,
didn't. Jesse, I think Jesse went up to 50 meters, and the horizon dropped back below eye level.
oh right, so this is a recent video that yes, I did see that Jesse had released a few. Oh right, so it's in a recent video he's actually done this. Okay, yeah, I did see. I hadn't looked at his recent ones. Oh, that's interesting.
Well,
Yes.
he did one that he showed it, and then he showed it from 3 different locations.
Excellent. Oh, I must have a look at that. Excellent. Oh, that's good. So then they say, well, yes, so we know that the refractions are varying things, so you do not do things. The Alberuni method of measuring the radius of the Earth involves you getting up on a bloody mountain where you get away from these sorts of intensive, outrageous effects. You don't get black swan circulating rays if you're at the top of a mountain. You still get standard refraction, but you don't get circulating rays.
The guy from the Maine surveyor, him and Jesse went up to Cadillac Mountain, about 1,500 feet above sea level, and they observed an ocean horizon. So I took the Maine surveyor's notes, and I ran through it. Okay? Now, that's a pure Alberuni. We've been told standard refraction is 7/6R. Okay? The guy in Maine, his notes returned 7.09/6R.
Right. Because of course that 7/6R is not awfully reliable because it does vary where you are in the world and of course the higher you get up and the more.
No, wait a minute. Wait. Yeah, if you're measuring 5, 10, 15, 20 miles, it's 7/6. Okay, he was on a mountain and he got 7.09. So as a rule of thumb, he's not off 1%.
And it's amazing. I'm surprised actually he got that close because I didn't think that figure was particularly right. That 7/6 is just a sort of average thing, and you can easily, even if you're high up, there's nothing rock solid about it. Because of course the more you're pointing down, so in other words, the higher you're up, and the more you point down, the less it's going to be. So, for instance, if you were pointing vertically down, let's suppose you were an incredibly high mountain. Let's suppose you were 10 mile high mountain, and you looked at the horizon. The refraction would almost be zero, and this is why Blue Marble's Eratosthenes technique works better, because you're looking at a high angle to the sun, whereas this business about looking near the horizontal, it's at its maximum effect, and the higher you are looking down, the 7/6R in fact will get less and less. The refraction will be smaller the more you're pointing down. It's not a good way to measure the radius of the Earth is to do this trick, an Alberuni just a few feet above the water. So my thing, I'm going to be doing this thing at 15, 20 feet up, and looking at these targets and things. And because I'm raising the targets, I'm not going in the really mucky stuff, but nonetheless I'll still be getting standard refraction, hopefully. But if I was to go up to a mountain, then I suspect, and looking down, then I'll get less than 7/6R. And of course, I'm trying to work out what this. I'm trying to actually measure the vertical temperature gradient to determine from physics what the refraction would be. Though actually, this is a somewhat unknown thing, as Eric has been, when part of his investigations with me. There are some people who say, well, actually, this vertical temperature gradient is not as reliable as you might think, and there are other things that you can allow for to actually work it out from physics. What your refraction, because of course the way that people actually do it, if you do want to know what the what the refraction actually is, rather than trying to work it out from theory, you can use a simultaneous reciprocal zenith measurement using two surveyors with two things pointing at one another, and they can then work out what the actual refraction is there and then actually measure it. So you don't even need to try and calculate it, which is what I'm trying to do. I don't have two reciprocal things pointing at one another. You can actually go and measure the damn thing. Exactly.
Well, and keep in mind, it's not whipping around like a bullwhip, like, oh, it's plus, it's minus, it's plus. No, you're going to end up with small percentages. It's not hypercritical.
Well, I might, on the observations I took of Rect, the one that I have managed to do, which is just part of the testing procedure, I was getting my targets moving up and down by the size of the target over a distance of 6 miles. So, I mean, okay, that's a small percentage difference, but nonetheless, in terms of what I'm doing, it's moderately significant, and that happened over a period of about half an hour.
And was it midday?
No, this was in the late afternoon.
Ding, 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 ding. What did I
Yeah,
say
yeah, yeah.
about not using late afternoon?
You did, Larry. Yeah, I mean, I'm with you on this. Yes, it's when it's varying. So yes, obviously when it's static and things, as you say, noon or something, then that's fine. But yes, this was about 4 o'clock, I think, in the afternoon, and yeah, I'm not disputing these things.
You want the most reliable adiabatic temperature gradient.
Well, I can measure it. I've got.
That's what adiabatic rate is.
Well, I know what you're talking about the theoretical rates that occur if you model it as an adiabatic thing. But I'm actually going to be measuring these things, so I can actually get the temperature gradient, and then you can then decide what the refraction is, depending on how you want to model.
Very good, very good. But just and yeah, it's going to take you all day. So,
yeah.
But the midday, that's the golden hour.
I agree with you. As I said earlier, that from the papers I've read and things, and with George's experience, I know that certainly in the early to late evening, well, early to mid evening, then you get quite often you get these circulating rays. Basically the black swan scenario actually occurs if you have a clear day, sunsetting, then you will likely to have circulating rays in that scenario. So I completely agree with you. Yes, avoid that if you want to take a decent measurement. And hopefully my measurements will reflect this. I'll be doing this over the whole period of a day, and hopefully it will show that the measurements at noon will give me a closer result than the ones in the evening.
Any update on your timing?
No, I haven't. I'm afraid I've been a bit. Things have been interfering with that, and also George is having his own problems. I was hoping to bring him over here, so I'm hoping within a month. That's basically what I'm hoping with now. I've been a bit delayed by some various life things happening to me, but hopefully I'll get those back on track now. And I'll be making some videos about all this, about the procedure. I've got quite a lot of video footage to do, and I just need to turn it into some proper videos and things. And yeah, so I've for various reasons I've not been able to get on with it as much as I'd like. So yeah.
You pointed out that Eric's been helping you behind the scenes, and I want to point out that he helped me a lot with Cavendish too behind the scenes.
Oh, did he? Oh,
yeah, he was looking at. Well, actually, he introduced me to Tracker and did a lot of analysis and stuff along with me.
Yeah, I mean, actually, I think 95% of the things Eric found I'd already found, but it's still useful to have someone else coming along, and he also did help me with a bit of Excel stuff as well. So, nonetheless, it helped me to. Playing around with Excel is quite fun, and generating nice graphs and things. And Eric's quite good at that as well.
I remain very grateful to Eric for all the work he did. Just having another set of eyes looking at it.
Yes.
Coming out of an environment where I was in an engineering office most of my life, so we always had somebody else, that you could that was going to take a look at it. And it feels pretty lonesome when you're sitting there by yourself, thinking, what did I did? Wait a minute, let me check that again.
Indeed. I mean, you must have had the problems when you were making these things, and when I was making these things, I'm thinking, I'm just doing this, and I have no idea if this is going to really work or something, and you really do feel scared about it all, and then it does sort of work, and it gets really it's quite an emotionally dramatic environment when you do this. I don't know, you must have had a number of dramatic moments for you. And for me, when suddenly things worked, you could see something, and oh my God, we can actually get a decent view. I can see along this 8-kilometer row, and this thing's in the right place, and I managed to see it, and this target's worked, and I've been able to, and just even mechanical things, like just trying to build things that actually can haul something 30 feet into the air, and oh dear, it's just so many little achievements. No doubt you've been through the same thing with your thing.
Oh, absolutely.
It's quite an emotional roller coaster, isn't it?
Well, yeah, you it's not the sort of thing you know how I knew how much work I was about to get myself into, and the last thing I wanted to do was try to take any shortcuts or not thoroughly analyze what my proposed hang on a second, let me see something here.
And of course, George, while you're doing that, George actually was a big. While I was designing how to do these hauling things and targets and how to move them up and down. Although George wasn't very keen on me being able to do telescopic. George was. The great thing about George is being an engineer. He's got lots of stuff in his garden or something. You know, can say he could go and does a 4x2 piece of wood fit inside a tube or something, and then George would just have these things in his garden and be able to go and prod them and then stick them in and say yes, that goes. Or he'd make a suggestion about how to use bearings and things. So it's having an engineer to hand is really useful.
Yeah, I did stuff like this up front to figure out the way that thing was going to behave. That's a spreadsheet that calculates all of where I use that to work out all the timing and wire sizes and things I was thinking about using. Yeah.
Yeah, and you did all that before you did all those calculations, didn't you? Before you cut a piece of wood, didn't you?
Yeah. Yeah, I didn't want to get it wrong.
Measure twice, cut once.
Yeah.
I mean, you had enough problem with wires as it was, wasn't it? Didn't you?
I didn't really have any problem with it as such. It might have looked like that, but actually, I started out thinking that shut that screen thing off. There we go. I started out thinking that I would be able to duplicate even the type of wire that Cavendish used. Turned out that wasn't possible because that material is just not available anymore. What Cavendish was using.
You're making a dreadful racket.
I finally figured out that what Cavendish used, he called a silvered wire, but that was a term that they used for what they called white copper, which was copper with a lot of nickel in it. It was some material that was available back in that time, out of China, I think. So it had a much better tensile strength than what you buy for copper nowadays. Is 99.99% pure copper. Yeah. So I was never able to find any way to come up with copper that would work. I tried beryllium copper, but that stuff's too damn springy. That's what it's used for. So in the process, I messed around with stainless steel and regular steel and different things, just playing with it to see how they behaved, and reverted back to what everybody uses anyway, which is tungsten.
What do you mean by springy? Isn't that a good thing?
Turns out not so much. The oscillations would be rather erratic, and not really erratic, but you didn't see a perfectly damped oscillation like you think you should see. One peak would be one extreme would be high, and the next time around it might not. Instead of decreasing, it might stay the same.
Right, it wasn't consistent.
Yeah, I don't think it didn't really seem to have a big impact on the accuracy, because I did run several tests with it and got about the same average that I got with all the rest of the tests. But I just decided I'd keep trying different things just to get an idea how different material might behave. It turns out if you're ever going to build one of these things, just don't worry with it. Bite the bullet, spend the money, and buy the tungsten.
Right.
Jesus Christ, that stuff is expensive, though. 25 feet of that stuff cost me $80.
Okay, but in absolute terms, it wasn't a huge amount of your
overall
budget.
No. But you think of 0.007 inch diameter piece of tungsten wire, 25 feet long, and the guy wants $80 for it. Are you crazy? What the hell?
Vroomfond asks in the chat, what makes you think it was a mistake for them to do it with max refraction rumpus and deliberate? I didn't quite. Was he referring to? I'm not quite sure what Vroomfond was referring to there. they did it with maximum refraction. I think I don't quite understand what he means. In other words, Rimfondle, you do what Larry was saying. You want to avoid them. I don't know. He's referring. I think, well, whoever you're referring to, presumably it's a flatty. They're obviously idiots, and they just like to get black swan type effect. They're only interested in the effects that invalidate the globe Earth. So, whatever you're referring to, presumably they like to cherry pick the one that is most problematic for us. But obviously for, they cherry pick. They pick the most awkward things. And if you've got circumstances in the evening where it's maximum refraction, that's when they're going to pick it. And BLSM 69, he picked that those were the made videos only of when the black swan, right? Yeah, and the black. So yes, I mean he said himself that he would go out there 30 times or something, not get normal refraction, get the pictures we've normally seen of the oil rigs, and then on one day, one in the evening, he will then get circulating rays. And obviously that's the one he's going to make a video about it, because that's the one that makes it is most difficult to explain. But not well, if supposedly for us, but of course we just say, well, it's refraction. That's what it does. It changes. You can get circulating rays where they makes the Earth look flat. But obviously that's what they're going to offer you. They're going to offer you videos like the black swan, which suggest that the Earth is flat. If you took that picture literally and you assumed there was no refraction, you'd have a flat Earth there. You said that. Oh, right. Okay. Yeah. So they're shooting low. Yeah. I don't know whether they do understand. Yes, they do shoot from being low, and perhaps that is deliberate. Yes. I think they know. I think he knew that that's the only situation in which he got the black swan type look, because when he went higher up, he's got a video. I can't remember for absolute fact now, but I thought there was a video in which he included on the same day. He did it from 30 feet up that drive, whatever it was. He didn't get the effect, or much less, as Chike was saying. And then he went down, he got the effect. So obviously, from his point of view, he's a flat earther. If he goes at 30 feet, 30 meters, was it 30 feet or 30 meters? Can't remember now which. He doesn't get an effect that he wants. Goes down low, and they're obviously going to be inclined, therefore, to keep sticking it to the low thing. And of course, Ranty did the same thing. And of course, Riley, in this document I've been doing for 2 years about the Isle of Man observation, he got the shore-to-shore observation over 50 kilometers. Only when he went down and lay down on his tummy on the seashore about 6 feet above the water, then he was able to get the shore-to-shore observation. When he was higher up, it didn't happen. So yeah, okay, yeah. I mean, I tend to think of them being more stupid. If I can, Rimfondle, I tend to think these people just tend to be stupid. Obviously, there are those that are dishonest, but I try and go for the positive side. I try and believe they're just being stupid. And obviously, once they've convinced me they're being malicious about it, I think. But even the malicious ones, I think, spend most of their time being stupid. And I prefer to believe that they're stupid rather than malicious. Although obviously some of them are malicious at least some of the time, but they're not malicious, I think, all the time. They actually try and do, from their point of view, they're trying to be honest most of the time, and then just do something stupid. But yeah, I mean, you could be right. I just go for I'm very reluctant, for instance, people call liars. I mean, Riley I have called a liar, because when there was occasion when he was claiming about the height he was in the Isle of Man observation, he said he was at 35 feet, and then we've got a picture of him with a 100-foot tape with his leg in the picture, when he claimed he was only at 30 feet, and then he's measured it with his tape measure. When Oakley was there, we've actually got a picture of him doing it from 100 feet, so we know for a fact there he lied. And there are other things we know he has lied about. But I'm reluctant to. I much prefer to not assume the motive, but just go with what they've done and then dismantle that. So, but I being cynical, I think is it's not productive. Just go with them being stupid. I think is much the easier way, because otherwise you have to sort of try and see into the mind of the person. Just point out they're doing something stupid, and if they're doing it stupid because they are doing it for deception purposes. I mean, someone like Bev, for instance, he does try and deceive deliberately. He's another person who does deliberately deceive, but he spends a lot of his time just doing stupid things, saying stupid things, and then he spends another portion of time actively lying or actively deceiving. So yeah, so you might be right, Fondle. I'm not giving them that trust. I'm just saying I'm going to assume, even if I suspect otherwise, I'll just go for the stupid option most of the time. Sorry about that. Sorry if I've taken that over there. Shut up now. I mean, Blue, for instance, I think they're a bunch of lying, deceiving wankers. I don't know whether Larry there thinks they're lying all the time. I tend to think they're being more stupid. But they're obviously both. I mean, so there's the stupid bit, and there's the deceiving bit, And I think they're doing both, but I think the vast majority is being stupid. But Blue thinks probably they're a bit more lying than I do.
Well, on a selective basis, yeah. There are some that I'm absolutely sure know better. And Bev's one of
So
them.
do you think that those people almost understand, say, 90% of what they're doing and then lie about it, or
Yeah.
do you think they're sort of, it's more like they lie about, say, 10% of what they're doing, or what ratio do you think?
Oh, I think the majority of what comes out of them is intentionally slanted. Maybe I shouldn't say they're lying, but they're manipulating the observations, the words, the data, everything to suit them.
Right. I think some of them, I wouldn't say they're lying, but they actually believe, like let's say Travis, for instance, he believes that when there's whenever there's a mirage, that those mirages happen everywhere, and that's why we call it Earth curve because of a mirage. And Rakia thinks that every time we're looking at an option, something that's hidden by the water, that's a mirage also.
Yeah.
I think that he really believes that. He thinks every time we look over water, it's a mirage that's creating that effect of something being obstructed by the water. But it's actually flat in his mind.
Yeah, he thinks mirages are the cause of missing the things being cut off, even though an mirage, for instance, if you're looking at a distant mountain that's 1,000 feet high and you're missing, say, 500 feet, and there's this thin strip of mirage, so it just doesn't work. You get a thin bit of mirage, and you're missing much more than the size of the mirage. You're missing, several, almost a degree. Some of these mountains you can see, one of those in Washington State, or whatever. You're missing half the mountain, and the mirage is only a tiny, tiny strip in comparison. So it cannot be responsible for hiding, a great section. Looking at the image on screen, there's a strip of a few pixels, or say 10 pixels of mirage, but you're missing, say, 500 pixels of the bottom of the mountain.
Right, but even when there is clearly no mirage, he thinks that is a mirage. The obstruction itself by the water is the mirage.
Yeah, but I mean, you can clearly see. Right, but I say his argument doesn't work because even when there are bits where it's clearly not a mirage. I mean, a mirage by definition is something that's inverted. So if you go to the point where it's not inverted anymore, it's still being, even if you allow for this band of inferior mirage covering things, as I say, for big objects that are missing a lot. I mean, obviously they can get away with it. He can get away with it when he's looking at boats and things that are only, say, a few pixels high. Obviously they can go and hide in the inferior mirage. But so then you say, well, don't deal with that. For instance, an example I've got is off the Isle of Blackpool, where Ranty lives. There's this wind farm, and so you're missing. You're just getting the tops of these wind turbines, and you're missing 80% or more of the wind turbine, and you can see where the inferior mirage is just a narrow band, just taking a bit out of the, where the wind turbine blades are. But from the design of the wind turbines, you're missing a great what else. So even you can pull apart his claims quite easily. But yeah, he does genuinely believe, and in fact, he's come up with a mechanism, didn't he? He's now churning out these smaller videos. He used to just do these ridiculous videos about 3 hours long of him just looking at a piece of the sea, doing not very much. But he's recently, actually, I think it's 6 months ago, he came up with a theory. He claims to have written a paper which explains that refraction comes along horizontally. He's now I haven't fully understood this, but he now claims it's not you're not missing vertically. Somehow these mirages are horizontal features on the surface of the water or something, and not vertical. I mean, he's just made up this whole new physics that you can only do that if you're completely committed to this insanity.
Yeah, well, luckily that paper got taken down.
Did it?
Yeah, you didn't hear about that?
No, sorry. Tell me about it.
John Hawkins got a hold of the people that run the website, Hyperphysics. Can you hear me?
You're occasionally fading in and out. Oh, right. So Isaac, I've forgotten who he published it with. Hyperphysics, you say?
Yeah.
Yeah.
Yeah, and
Well, you can
Sean,
probably tell them better than I can, since I'm breaking up.
yeah, Sean got a hold of them and pointed out the problem, and then I guess they took a close look at what the thing really said and took it down. Is that basically it?
But how did? Sorry, they accepted? I can't cope with this. You're saying they accepted something from him and put it up on their website?
Yeah.
Oh my God! Oh Jesus!
Yeah, it was up on Hyperphysics for.
But to be
weeks.
clear, there's a lot of what they call them predatory publishers. He might have had to pay to have that published, and they just stick it up there and see who salutes. Yeah, they don't proof it, they don't jury it. I think it's pay to play. They call them predatory papers.
But Hyperphysics.
Predatory journal. Predatory journal.
We're talking about we're not talking about the Hyperphysics website, because originally the thing that Travis was interested in was off from the Hyperphysics website. But you can't contrite to that. Is this not another online journal?
Oh hell
It's
yeah,
not
you
the
can.
Hyperphysics website.
That's what he had it on there. That's the site he had it on. It was on
Jesus
Hyperphysics.
Christ! But that's a. Oh my God! Jesus Christ! Yeah, Sean says I haven't heard news. Indeed, Sean. Yes, well done, Sean. Jesus Christ! I didn't realise that had happened. My God!
Well, it unhappened.
Okay. What happened was Travis had an interview with some guy, the guy who runs the Hyperphysics website, who posts things for the physics department, and he was under the impression that Travis was a honest, truth-seeking person who likes science, and Travis basically misrepresented himself and his position. The guy posted the article. Travis posted the link. I read it, and I contacted the physics department, who actually is in charge of the website, right? I mean, they're in charge of all the information that goes in. He's just an ex member of that department. So they give him privilege. They give him posting privilege. Well, he did it without their permission, but because he really didn't need to. So he put it up there. I contacted the physics department. They looked at it and basically had a special meeting just for Travis and took it down.
Bloody well done, Sean. Well, thank God for that.
Yeah.
Jesus Christ. My God. Because that Hyperphysics website's pretty good. I mean, it's quite respectable.
Yeah.
It's outrageous.
And Travis, all Travis did was take the original article by the guy, I think, who he interviewed him, or who he interviewed, and changed it. He plagiarized it basically and altered it.
I mean, it wasn't a great article. I have to say the Hyperphysics article does have some errors in it. It did have some errors in it. With Jesus Christ now is, oh dear. Yes, I wasn't too impressed with that article. And then and actually Travis used to have videos saying, "What the hell is all this bollocks?" He couldn't understand any part of it, and he said so. So the idea that he then played, but this did seem to be his favourite one. So the idea he went through it and then changed it to that bollocks, which I read parts of his thing. I didn't even fully read his paper. Jeez, well done, Sean. Jesus Christ.
Well, thank you.
Oh, bloody hell. Thank you. Well done. God. That's out, because that is a respectable website.
Yeah, it's a place where high school kids go to learn. Yeah. And we don't want stupid high schoolers. They're stupid enough as it is. Shit.
Yeah. Well done, Sean. Golly goodness. Whew.
Yeah, it was wild.
This is almost as incredible as bloody Riley and his paper, his thesis that he put up, which basically had the spelling of a 14-year-old and the logic of a 13-year-old, to that submission to the universities in this country. Jesus Christ. Oh, but bloody hell, that's a bit shocking. I mean,
Travis
the guy
is,
must have read it. I mean, the guy must have read that if he submitted it to him. You'd thought even that, as I say, I don't think it was a terribly good article. I think there were about 2 errors in the graphics that were included in that article. But even so, he must have realised that what Travis was saying was complete bollocks. Or perhaps he didn't bother to read it.
probably didn't bother reading it.
Yeah.
Looked good, and he cleared it because he got a good impression from Travis. Travis seemed to know what he was talking about because the guy admitted in the interview that he isn't really well versed in miraging. He's more of a just an optics person.
Right.
And Travis is not happy about it.
So how do you know? How did you get this information about the guy? Has he communicated with you or something about why? You say he's not an expert in optics. How do you know that? How did he communicate that to you?
He said that in the interview. He said, "I'm not real familiar with miraging. I'm mainly an optics."
So this interview was an interview between Travis and him.
Yeah, and it was Travis. It was Travis. You've seen how Travis presents himself when he does his live streams, right? With all kind of flat Earth stuff and all kinds of garbage in the background. He had none of that in the interview.
So I'm a bit confused. This interview. So where are you? He recorded the interview, and then you've watched the interview that he had via Travis.
Right. He posted it to his. He did the interview live on his channel.
Right.
And he posted it to his website.
I see.
Or to his YouTube channel.
And the guy who was talking to in this interview admitted that he wasn't an expert on miraging. Well, that explains why that article was so poor and had a couple of basic mistakes in it.
Yeah.
Oh, dearie me. Yeah, I mean, at least Travis is quite well spoken. I mean, he's got some sort of master's, hasn't he, in theology or something. He can put a sentence together. There's no disputing that. But obviously, he knows nothing about science at all. I mean, he's incredibly ignorant of science, but he can put a sentence together, and so presumably, by simply repeating back to this guy what he had in his original article plus a bit more, obviously managed to confound him. Jesus Christ.
And not only did he misrepresent himself about his position and what he believes, the guy said, well, what about things going over the curvature? And Travis said, well, yeah, we'll get back to that. And never did. Never did.
Oh, that's shocking. I'm going to have to go and lie down.
Yeah, where is that? Did he take that interview off his channel? Because I can't find it.
I don't know. I'm not sure. I'll have to look.
Because he claimed that he never said that, and I need to find that.
Yeah, I don't know. I'm not sure.
Because I made a joke about it the other day on Geo. That I said I was like, well, sorry, hyperphysics didn't agree with you, and then we had a whole conversation about this topic right here. So yeah, he's pretty salty about it.
Oh, he's butthurt, big time.
Oh yeah. Mm-hmm. So I'm thinking, because then I said, well, I said exactly what you were saying, Sean, how he talked about the gentleman mentioned the curvature of the Earth, and then Travis said they'd get back to it, and then they never did. And he claims he never said that. So I would like to find that clip and clip that out.
I'll look for it. But yeah, it looks like he took the interview down.
Can you blame him?
Yeah.
No.
And I see we've got Gary Y. Benger in the chat saying horizons are simple optical limits from compressed angles, not realizing, of course, there's nothing compressed about the angle to the horizon. It's no more compressed than anything else. And the Rayleigh criteria has nothing to do with what angle direction you're looking at.
You can't compress light. It's incompressible.
That's the lemon bird smushing, squishing.
Yeah.
I found the article. I found the interview. Hold on.
Yeah.
Yeah, here. Let me put a link to it in the text chat. There we go.
And put it in the YouTube chat as well.
Yeah.
Gary Wybenger, visual space is compressed with distance. What the hell? I mean, he's obviously got no understanding of geometry whatsoever. Unbelievable. Based on nothing more Go away and do some calculations, Gary. Go and work out how big something should be at a distance of, say, 10 miles that's, say, 6 foot high. Come back to us and tell us what the angular size will be, and tell us how it depends on whether it's high up or low down. Show us the maths for that, and then we might be interested in talking to you. Anyway, I've got to go anyway, but that was well, thanks for I'm just really glad Sean was on the case there. Bloody hell. Jesus.
Yeah.
Hey, Sean, did you say he took that interview down?
No, I found it. And I posted the link to it in the
Awesome.
live chat Discord and in the YouTube chat.
Awesome.
Yeah, I'm trying to find the timestamp for it. I'll find it.
It's like towards the beginning, I think.
Yeah, about between 5 and 10 minutes in. Yeah, I'll find it, I'll clip it, and then I'll post it special on my channel as a video.
Just go on the website. I mean, the website. Go on the comment section, and post a timestamp.
Okay.
Wait, you're not blocked from his channel, are you?
Oh yeah, absolutely.
Oh, so I probably won't even see your comment.
Yeah.
All right, yeah, just post a timestamp in here somewhere.
All right.
Appreciate it.
Well, we're 2 hours and 50 minutes into this, and I think it's about time to say goodnight to the YouTube crowd. We can hang around in here as long as you guys want to. But I'm getting a little hungry. Time to go look for something to eat, I think. Hey, everybody.
Starvation's setting in, is it?
Yeah.
Raid the fridge.
I don't believe I'm in danger of starving anytime soon. I've got enough stored up to tide me over through the balance of the summer, I believe, but that's okay. Anyway.
You can live off the fat of the land.
Yeah, absolutely. Yeah, that's one of the privileges of getting old. You can just be whatever size you want to be. Nobody cares anymore. But anyway, thanks for showing up, guys.
Thanks for having us.
Yeah, it's been an enjoyable afternoon. Nice way to spend the early part of a Friday evening, or the late part of it if you're Rumpus, or you guys in other parts of the world.
Or an early part of a Saturday morning.
Or the early part of a Saturday morning, exactly. So with that, bye-bye to all you YouTube people. We'll see you next week sometime.